Enak rasa tak terabaikan, cita rasa sungguh merata. Sebelum acara kita mulakan, ucap salam pembuka kata. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera kami ucapkan kepada seluruh audiens dan para narasumber, baik yang telah hadir secara langsung di ruang Amphitheater Gedung Gurindam Ismet Abdullah, Universitas Maritim Raja Ali Haji, maupun yang bergabung secara daring. Puji syukur kita panjatkan kehadirat Allah Subhanahu wa Ta'ala, karena atas rahmat dan karunia-Nya kita dapat berkumpul bersama pada pagi hari ini dalam acara Konferensi Internasional MARINESTIC 2025.
Good morning, distinguished guests, honorable keynote speakers, and all participants, both those who are joining us on site at the Amphitheater, Satu Gurindam Ismet Abdullah Building, Universitas Maritim Raja Ali Haji, and those attending virtually. Praise be to Allah Almighty for giving us the blessing and opportunity to gather here today at Maritime Research on Innovation, Environment, Science, and Tradition International Conference 2025.
Kami informasikan bahwa acara ini akan disiarkan secara langsung melalui kanal YouTube FKIP UMRAH. Kami juga mengimbau kepada seluruh hadirin untuk dapat menonaktifkan notifikasi telepon atau menyetelnya ke dalam mode senyap agar acara dapat berjalan dengan lancar.
This event is being broadcast live through the official YouTube channel of FKIP UMRAH. We kindly ask all on-site participants to turn off or silence their mobile phones and other communication devices to ensure the event runs smoothly.
Hadirin yang kami hormati, izinkan kami mengucapkan selamat datang kepada para narasumber yang luar biasa pada pagi hari ini. Yang pertama ada Bapak Profesor Dr. Tatak Yuli Eko Siswono, SPD MPD, yang telah membersamai kita di ruangan hari ini. Lalu yang kedua ada Bapak Dr. Ahmad Husaini Mohammed. Yang ketiga ada Bapak Christian Adiputra, PhD, Profesor MV Reddy, dan Ibu Elia Tena Galego, PhD.
Distinguished guests, please allow us to warmly welcome our honorable keynote speakers. First, we have Professor Dr. Tatak Yuli Eko Siswono, SPD MPD. Then we have Dr. Ahmad Husaini Mohammed. Third, we have Sir Christian Adiputra, PhD. Fourth, we have Professor MV Reddy. And lastly, we have Miss Elia Tena Galego, PhD.
Untuk mengawali rangkaian acara pada pagi hari ini, marilah kita bersama-sama menyanyikan lagu kebangsaan Indonesia Raya dan akan dilanjutkan juga dengan Mars Umrah. Kepada seluruh hadirin, kami mohon untuk berdiri.
To begin today's session, let us sing our national anthem Indonesia Raya, followed by Mars Umrah. Ladies and gentlemen, please rise.
Jati
Hadirin disilakan duduk kembali.
The audience may be seated.
Bapak, Ibu, dan hadirin yang kami hormati, marilah sejenak kita menundukkan kepala, seraya berdoa, memohon kepada Tuhan Yang Maha Esa, agar seluruh rangkaian acara pada pagi hari ini dapat berjalan dengan lancar. Doa akan dipimpin oleh Saudara Muhammad Harun. Kepadanya disilakan.
Honorable guests, let us take a moment to pray to the Almighty God so that today's event runs smoothly and successfully. The prayer will be led by Mr. Muhammad Harun. To him, please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hadirin yang berbahagia, sebelum kita mulai acara kita pada hari ini, marilah sejenak kita menundukkan kepala, mengangkat tangan, bermunajat pada Tuhan Yang Maha Esa. Semoga acara kita pada hari ini dapat berjalan dengan lancar. Doa akan saya pimpin menurut ajaran agama Islam. Menurut bagi yang beragama lain dimohon untuk menyesuaikan. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin, hamdan syakirin, hamdan na'imin, hamdan yuwafi ni'amahu wa yukafi'u mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalal wajhikal karim wa azimi sultanik. Allahumma salli ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad. Ya Allah ya Rahman, pada hari ini, di ruangan ini, kami hendak melaksanakan kegiatan Marinestic 2025 dengan mohon izin dan ridhomu. Berkailah semua langkah dan perbuatan kami, dan jadikanlah itu semua amal ibadah dan nilai ilmu yang bermanfaat pada kami. Ya Allah, Ya Allah ya Wahid, Engkau yang Maha Satu lagi Maha mempersatukanlah. Perkuatlah persatuan di antara kami. Kami ingin kuat dalam persatuan itu agar dapat lebih bermanfaat pada agama, nusa dan bangsa ini. Ya Allah ya Ghafur, Engkau yang Maha Pengampun atas segala dosa. Ampunilah dosa-dosa kami, dosa kedua orang tua kami, dosa para guru kami, dosa para pendahulu kami, dan dosa para pejuang kami. Tempatkanlah kami dan mereka semua dalam lindungan dan rahmat-Mu. Ya Allah, ya Mujib, Engkau yang Maha mengabulkan doa. Perkenankanlah doa dan permohonan kami. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih kepada Saudara Muhammad Harun. Hadirin yang kami hormati, selanjutnya marilah kita dengarkan kata sambutan dari Ketua Pelaksana Marinestic 2025 yang akan disampaikan oleh Ibu Nurul Hilda Syani Putri, SPD MSc. Kepada Ibu, kami silakan.
Distinguished guests, let us now listen to the welcoming speech from Ms. Nurul Hilda Syani Putri, SPD MSc. To her, please welcome.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi semuanya. Selamat datang Prof, Pak Feb, dan Pak Dios. Puji syukur kehadirat Allah kita panjatkan. Karena atas berkat rahmat-Nya lah kita dapat berkumpul bersama di ruangan ini dalam keadaan sehat walafiat. Salawat dan salam Tak lupa pula kita haturkan dengan mengucapkan Allahumma sholli ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad. Dear distinguished Honorable Keynote Speaker, Profesor Dr. Tatak Yuli Eko Sisono, SPD MPD, respected speaker and participant, selamat datang di Marinestic Seminar Internasional FKIP UMRAH. I'm very happy to see all of you here today. This conference, with the theme Marine System and Scientific Advance for Global Maritime Synergy, is a great opportunity for us to share ideas and learn from each other about the future of maritime studies. Indonesia is a maritime country. We live close to the sea, and the sea is our life. That is why this conference is important, to remind us how science and innovation can help us protect and use the ocean wisely. I would like to express my deepest appreciation to our distinguished keynote speaker, Profesor Dr. Tatak Yuli, for sharing his valuable time and insight with us today. Terima kasih Prof atas kehadirannya di tengah-tengah kami. Thank you also to all speaker, participant, and the committee who work hard to make this event happen. Terima kasih juga saya ucapkan atas kerja keras dan semangat semua tim. Tanpa kalian semua saya di sini nggak ada apa-apanya. Let us start this conference with an open heart and positive spirit. Semoga kegiatan ini bermanfaat dan membawa ilmu baru di bidang kemaritiman. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih kami ucapkan kepada Ibu Nurul Hilda Syani Putri atas sambutannya yang begitu luar biasa. Hadirin yang kami hormati, selanjutnya kita akan memasuki sesi pemaparan materi pertama yang akan dipandu oleh moderator kita, Bapak Febrian, SPD, MSc. Pada Bapak, disilakan.
Ladies and gentlemen, we will now begin the first plenary session led by our moderator, Mr. Febrian, SPD, MSc. To him, please welcome.
Bismillahirrahmanirrahim. Air beriak, tanda tak dalam. Air tenang seperti berlian. Izinkan saya ucapkan salam untuk para hadirin sekalian. Assalamualaikum warahmatullahi wabarakatuh. Izinkan saya memandu sesi ini dalam bahasa Inggris, boleh? Okay. Greetings, distinguished keynote speaker, honorable guests, respected presenters, and all participants of the first Maritime Research on Innovation, Environment, Science, and Tradition International Conference we call MARINESTIC 2025. On behalf of the organizing committee, I would like to extend a very warm welcome to all of you. My name is Febrian, and I am a lecturer of Mathematics Education Study Program at the Faculty of Teacher Training and Education, Universitas Maritim Raja Ali Haji here in Tanjung Pinang. And I feel like I'm absolutely honored to be the moderator of this keynote session. This conference, hosted by the Faculty of Teacher Training and Education, Universitas Maritim Raja Ali Haji brings together educators, researchers, and practitioners to share ideas and innovation that drive the transformation of education in the era of artificial intelligence and sustainability. Today, we are privileged to have with us Professor Tatak Yuli Ekosiswono. Please give a round of applause right now. Professor Tatak is a senior lecturer from Universitas Negeri Surabaya. He is also a head of doctorate program on mathematics education in his affiliation. Professor Tatak is profoundly a prominent researcher in the field of mathematics education. To this day, Prof. Tatak has made significant contribution to research on mathematical thinking, teacher of professional development, and contextual learning approaches that integrate socio-cultural and ecological dimensions into mathematics education. The keynote he will deliver today to us is titled, "How do mathematics educators interact with AI in designing socio-ecological based mathematics learning," which is a very interesting and insightful topic, right? Yes. This presentation will explore how mathematics educators can engage meaningfully with artificial intelligence to design learning experiences that are not only effective, but also socially and ecologically responsible. A perspective that is increasingly vital in today's interconnected world. Before we begin, let me kindly remind all participants here to keep your ringtone off and microphone muted, as well as maintaining silence during the presentation to avoid background noise and to sharpen our focus. With those reminders, ladies and gentlemen, let us give our full attention and warm round of applause once again. Yes. To welcome Professor Tatak Yuli Ekosiswono here in the podium. Time and place are yours, sir.
Thank you very much, Pak Febrian, moderator in this session. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin. And good morning all participants. I will open this session use pantun. This is it's like a poem. Right. A boat sails gently on the sea. The breeze brings song on bright delight. We share our thoughts in harmony. Marinestic seminar shines so bright. Thank you, distinguished rector of Universitas Maritim Ali Haji UMRAH and Vice Rector, Dean of the Faculty of Teacher Training, Education, Vice Dean, and also honorable fellow keynote speakers and all participants. I will, in this session, express my sincere gratitude to the committee because very kindly for inviting me to share a few thoughts in this important seminar. Today I will speak about how mathematics educators interact with artificial intelligence or AI in designing socio-ecological based mathematics learning. These topics stand at the interaction of three great challenges of our time. The first is mathematics education, socio-ecological awareness, and artificial intelligence. Mathematics is often seen as abstract and detected from social or environmental realities. Okay, next please. Right. Yeah, today we have some challenge about the social and ecological problem in our or surround in living in daily living. We know some kind of, for example, social problems like poverty and also social ecological problem like deforestation, and in Tanjung Pinang I think there is some problem marine pollution and others topic in social ecological. But as a mathematics educator, as an educator in commonly, I think what is your concern? What is our concern? What we are doing? Next, as a mathematics teacher, I think we notice some problem and bring the problem in classroom situation connected with the mathematics as a field or main field in teaching and learning process. Our lesson or procedure actually just teach mathematics concept. Yeah, because this, I think this is job. We must deliver mathematics concept to student because mathematics is abstract. So we deliver mathematics with the abstract. It's not related with the situation in daily life or maybe problems in social ecological. So the real question is how can mathematics learning foster awareness and responsibility toward this issue? And we know, next maybe, right? Yeah. As a teacher, we need a socio-ecological issue actually, and mathematics topic related, and as a teacher, we design lesson plan and then implement it in real classroom. We use artificial intelligence. Next, yeah, we use artificial intelligence like ChatGPT and others. I think this makes sense in this moment because we know AI is in daily life. We use AI as a partner, not only for help or assistance in some jobs, but also in like in social or maybe in like in some aspect like a feeling. Maybe you are deep feeling like we try to make AI for discussion. Right? Okay. So in this aspect, artificial intelligence can do many impressive things. It can help us identify local issues that related to global problem. Because we have some limitation to understand social or ecological problem, because we just give attention on like a mathematical problem or student situation. For example, student can understand a topic in mathematics, how we must deliver, how we must handle this problem. So we must or everything in circums or surround of our life, we don't care. But actually, this social ecological is common in all situations. We breathe, and also we drinking something. Actually, is related with socio-ecological situation. It can collect, AI can collect and process real-time data, generate lesson plan, and even design evaluation tools. Yeah. But here in this essential question, do educators see AI as a partner in thinking, or merely as a servant to execute commands? So AI is treated not only as a tool for teacher. Teacher use AI may gain efficiency, and try to design deeply lesson plan connected with social ecological problem, with critical and also creatively to design. So the keynote in this aspect, understanding how mathematics educator actually interact with AI in practice, not only just in imagine, for example. Next. Mathematics educator traditionally consider abstract, and the text from social context is now challenging to respond to do what is force. Okay. In I conduct try to construct social ecological based mathematics learning in my study. I try to construct or make some principle with what is socio-ecological mathematics learning. And we find some article, and then I decide to construct some principle. There is 4 principle of socio-ecological mathematics learning, or SAML. Next. The first principle is socio-ecological connectedness. Socio and ecological system are inseparable. Mathematics learning should help students see this interconnection between human, nature, and technology. So in the first principle, if we design SAML, first we must connect it with the mathematics with a socio-ecological problem or situation. The second is a communal mathematics. Mathematics is not solitary act but a collective endeavor. We study mathematics, we understand mathematics, not only just one person, but we study and understand concept of mathematics actually is a communal situation. Learning become meaningful when students collaborate, share ideas, and act together. And the third principle is dialogic ethics. Ethical responsibility arises through dialogue, through listening to the others, whether that other is a person, community, or even the living world. And the fourth principle is student engagement. True learning happens when students are emotionally and cognitively engaged, when they question, reflect, and think critically about real issue. So SAML is not about adding green example to math problem. Just add socio-ecological problems spiritually, no. But this about transforming how students relate mathematics to living the world. From this principle, there are some characteristics. This next. This a principle. There is 4 principle. This is the last 4 principle is student engagement. Right? Okay, and next. This characteristic of SAML. The first is dynamic socio-ecological content, local and global. So in designing teaching and learning process, we must take a portion for socio-ecological. It's dynamically. And the second characteristic, interdisciplinary. So when we use SAML, we must try to find other knowledge in not only in mathematics concept, but in other. For example, in technology, in biology, in climate change, for example, and others. Some approach or discipline not only in mathematics education or mathematics. And then characteristic third characteristic is awareness and reflection. Awareness and reflection. I think this in line with the new curriculum in our national curriculum in Indonesia about deep learning. One principle is awareness, and the second is meaningful, and the third is enjoyable. But in this SAML, awareness and reflection is one of characteristic. Students discuss ethically implication, who benefit, who suffer, what justice mean in this context. So they reflect and awareness in living world, in daily living world. They have some problem. Maybe not student problem, but is a civilization or citizen problem. But student in the class try to awareness and reflection the situation. And the third is collaborative and social justice. Collaborative and social justice. This is a third characteristic. And four, building socio-ecological awareness and responsibility. Yeah. The characteristic, there is a dynamic social ecological context, interdisciplinary, collaborative and social justice, and four, building socio-ecological awareness and responsibility. All right. And fourth, this four, building, and then fifth characteristic, next. Active and reflective and critical. So in this situation, in teaching and learning process, we hope students not just a passive, they must active, asking question, try to criticize the problem, and also reflective. This is a characteristic of SAML. And sixth characteristic is issue or problem focus. So not only in mathematics aspect, but in issue and problem focus. For example, about the deforestation, poverty, for example, pollution, yeah. And seven characteristic is utilization of technology. Utilization of technology. Technology can be used as a tool to explore ecological data, visual relationship, and also collaborate and communicate findings. So using technology, I think, is makes sense and logical in this situation or in this era, I think. Okay, next. Yeah, this is how to implement in classroom activity. First, we must identification in this pace of learning. So, teachers give a task or situation or problem, and then the pace learning student promote to identification and contextualization of issue or problem. This and then that activity. And then next, interdisciplinary mathematical investigation. They try not only in mathematics aspect, they can combine with others field, for example, in biology and others, physical, economy, for example, and others. Interdisciplinary mathematical investigation. And the third, developing social ecological awareness and responsibility. Student can make a plan, activity, how to, for example, to handle the problem, how to give a suggestion, give, for example, like a formula to make this problem is not more complicated, for example. And fourth, next, action and communication. I think this is a main idea. So student, we hope student not only just make creative innovation, creative idea, or just report, but they also show action, show up an action and communication, presentation, for example. And then the fifth, iteration and adaptation. This activity actually student must adaptation and implement in daily life. Okay. Next. Yeah. In my campus, I design some small research about how teachers, actually this doctoral student, to design this SAML and try to implement in real situation classroom. And yes, as we present at the first presentation, as a teacher, we have a problem. We don't recognize social ecological problem. So we use AI to identify and try to find data. We use AI. And also in this situation, teachers or doctoral student in my research, they make a lesson plan. Yeah. We conducted a qualitative case study with 3 doctoral students of mathematics education at Universitas Negeri Surabaya. Each student was asked to use ChatGPT to design a full set of socio-ecological based mathematics learning materials, including lesson plan, teaching materials, worksheet, and assessment. We analyze their chat log, document, and reflection. Next, maybe. Yeah. The findings are quite revealing. Most of students interacted with AI in a linear and procedural way. Yeah, this is how we analyze this, live interaction log and documentary evidence, make a researcher memos on an observation. Next. Yeah, we analyze the qualitative data from use a thematic analysis. We use a document from student, from doctoral student, I mean. And with we analyze chat document, and the findings are quite revealing. Most of the students interacted with AI in linear or and procedural way. I mean is a doctoral student. They give comments such as, please make it, please revise this part, or make it clear. And the AI produced good-looking lesson plan, structured and coherent and grammatically perfect. Yet pedagogically they were shallow. There is just we can see that as pedagogically actually there is some limitation. For instance, for one lesson, use water use context, but the mathematical task was a simple inequality. Yeah, it's like 150x is less than 900, like this. So this issue was merely decorative. The socio-ecological problem just decorative, just put as just put in this as a contact spiritly with topics. The social issue was merely decorative. Another used pollution as a theme, but better, the data were simulated and unquestioned. Maybe next, Lisa, right? Students focus on calculating probabilities, not on analyzing causes or justice in pollution distribution. In short, the design looked at socio-ecological, but it did not think socio-ecological. It's mean, yeah, in surface that is look socio-ecological mathematic learning, but actually as a deeply actually not a novelty, not a good idea to give a contribution in socio-ecological problem. This reflects what we call the tool using paradigm. So I call this is a tool using paradigm. Just AI, just as tool to help to assistant or make a lesson plan, but teachers or doctoral students don't understand how to improve, how to give contribution or expand the contribution, I mean. They show procedural delegation and passive acceptance, relying on AI for the heavy cognitive lifting, but not engaging in critical dialogue. Even though They were expert in mathematics education. They were novice in human AI collaboration. These findings lead us to an important insight. The quality of human AI collaboration directly shapes the quality of educational outcome. Therefore, teacher education program must go beyond technical training. So we must give a technical training to design from in AI, so student or teacher can expand their knowledge, expand their lesson plan with the mathematic aspect or concept is increased, and also in social ecological more suitable or more credible. We must help future teacher develop critical prompting skill, how to ask, challenge, and refine AI response. Ethical and reflective awareness, understanding when and why to trust AI. Yeah, actually we don't AI very much, because sometimes AI make mistake. So we must AI, yeah, as a partner, but we try to criticize the AI or result on AI from AI. So collaborative thinking skill, treating AI as a partner for sense making, not just for writing lesson plan. In this way, AI will not replace teacher, but expand their humanity.
Excuse me, Prof.
Okay,
You're
thank you
approaching
very
the
much.
end.
All right.
Yes.
Yeah, the future of mathematics education is both socio-ecological and AI collaborative. We are not choosing between human and machines. We are learning how to think together, combining human ethics and empathy with machine intelligence and efficiency. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Maybe I stand next to you.
All right.
Yes, thank you very much, Prof. Tatak, for the insightful material. And I believe that we are here taking a good point from your presentations, like why mathematics is actually there in our everyday life. In this case, that you take the example of socio-cultural and ecological phenomena. And yes, somehow we cannot see mathematics formal in just formal way, but
Yes.
also it connectedness with our daily life.
Yeah, right.
And about the AI, you said that you have highlighted how artificial intelligence can actually serve not just as technological tool, but
Yes.
also as a partner.
Yes.
For example, a partner of a researcher in this case.
Yeah.
Thank you very much. So now we will have some short moment question answer. Ladies and gentlemen, if you would like to ask questions, unfortunately, maybe we only have one question. If you have questions, please raise your hand and wait for the microphone to reach you. Yeah. For online participants, maybe. Yeah, participants joining the conference virtually, feel free to type your questions in the chat box. Maybe we only have 5 minutes, sir.
Yeah.
Yeah. Let us begin with maybe first questions. Yes, thank you. Can you pass the microphone? Do we have microphone there? No? So I pass the microphone myself. So please tell your name and your affiliation.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Okay, let me introduce myself first. My name is Yusdawati Amelia Putri. I'm from the English Language Education Study Program. First of all, I'd like to express my gratitude to Mr. Tatang Yuli Eko for delivering such an interesting material. How do mathematics educators interact with AI in designing socio-ecological based mathematics learning? And I'd like to ask the questions: how do educators evaluate the effectiveness of AI-assisted socio-ecological mathematics learning? I ask this question because I'm curious how teachers can make sure that using AI truly improves students' understanding, not only in mathematics, but also in their awareness of socio-ecological issues. I believe evaluation plays an important role to see whether AI actually helps students learn meaningfully or not. Thank you for the opportunity.
Please give an applause. I believe your questions will be like how to assess the effectiveness of using AI in creating learning mathematics that used the socio-ecological cultural context. Thank you, sir. Can you respond to questions? Thank you.
Okay, thank you very much.
Yes.
First, this activity or design lesson plans for teachers, not for students. In teaching and learning situation, we believe that student must understand what we deliver mathematical concept or other concept. So to evaluate or assignment the effectively of student, we must I think this some tests, for example, or observation and others, and use a rubric, but not for use AI. I think in many school in Indonesia, we understand that student in classroom without bring without bring like handphones, so they I think traditional to understand the concept like a mathematical concept and others. But in teaching and I mean in for undergraduate student, for example, as a lecturer in teaching and learning, we can evaluate use rubric or like observation with the criteria what is the principle and characteristic, and also teaching and learning pace when prospective student, prospective teacher on make lesson plan like that. So the effectively is, for example, if the student or undergraduate student, they can show up some indicators like that. Thank you very much.
Yes, thank you, Prof. Tatak. I believe that Prof. Tatak said is no matter how efficiently or effectively we use AI, but the key concept is still the user itself. So the researcher have to really understand the principle of the SEML, socio-ecological mathematical learning in this case. So he really needs to understand the idea of that concepts, and then when using AI, she can do some reflections on the knowledge itself on the SML. I think that's all, sir. Yes. I think we are running out of time, and we are clearly approaching the end of the first session. To conclude our discussion session, here are some important points that we learned from the materials that Professor Tatak just presented to us this morning. Like the first one is human AI interaction quality is the key mediator of educational design outcomes. And current practice remain tools-oriented but not partner-oriented, right? To unlock AI's potential in education, teacher must develop AI literacy, critical prompting, I think that's the main point, being critical, and reflective use align with socio-ecological values. And ACML offers a framework for ethical, contextual, and sustainable mathematics education where AI supports human judgment, not replace it. Yes. And finally, thank you very much, Prof. Tatak Yuli Eko Siswono, for your valuable insight and thought-provoking reflection. Your presentation has offered us new perspective on how mathematics education can engage with artificial intelligence to foster not only cognitive growth but also social and ecological awareness among learners. On behalf of the organizing committee, I would also like to extend our gratitude to all participants for your active involvement and thoughtful questions during the session. Please join me once again in giving a warm round of applause to our keynote speaker once again. You may have a seat. Yes. This concludes our keynote session. The next session of the conference will begin shortly. So please stay with us. Thank you so much, everyone, and have wonderful continuation on the conference. But please allow me to read pantun to close this session because I open pantun and then close with the pantun itself. Oke, dari Kedah ke Pekansari, beli swasta di kota tinggi. Materi pagi ini sudah diberi. Semoga suatu saat bersua kembali. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih Bapak Febrian dan Bapak Tatak atas penyampaian materi dan juga pemanduan pemateri yang sangat luar biasa sekali. Beri tepuk tangan sekali lagi. Agenda selanjutnya akan diadakan yakni sesi foto bersama. Kami mohon kepada Bapak narasumber dan juga Bapak Ibu tamu undangan serta Bapak moderator dan juga para peserta untuk dapat berdiri dan juga mengambil tempat yang telah ditentukan. Kami juga memohon kepada panitia dokumentasi untuk dapat mengatur jalannya proses dokumentasi hari ini dan juga mengabadikan momen pada kesempatan hari ini. Kami mohon kepada Bapak, Ibu, serta para audiens untuk dapat berdiri terlebih dahulu dan juga menghadap ke layar. Ya, berdiri di tempat dan juga menghadap ke layar. Diharapkan kepada para peserta untuk dapat merapat ke tengah dan juga kepada Bapak Ibu undangan juga untuk dapat merapat ke tengah. Terima kasih. Untuk para peserta diharapkan agak mundur ke belakang sedikit dan juga agak merapat ke tengah agar masuk ke dalam frame. Ya, mungkin bisa dirapatkan kembali ke tengah untuk para peserta agar semuanya dapat masuk ke dalam frame. terima kasih atas seluruh partisipasi yang telah diberikan dari para peserta dan juga Bapak Ibu undangan serta Bapak narasumber dan moderator. Selanjutnya kita akan beristirahat sejenak untuk coffee break selama 5 menit.
Thank you. We will now have a short 5-minute coffee break. Please enjoy your refreshment and we will resume shortly.
Bapak Ibu hadirin yang kami hormati, untuk sesi coffee break kita kali ini telah habis dan selanjutnya kita akan melanjutkan ke agenda pemaparan materi kedua dan juga ketiga yang akan dipandu oleh Ibu Elsa Ernawati Nainggolan SPD MPD.
Honorable guests, we will continue to the second and third plenary session led by our moderator, Ms. Elsa Ernawati Nainggolan SPD MPD. To her, please welcome.
Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Good morning, good afternoon, and good evening to all distinguished participants joining us on site and virtually from different parts of the world. Welcome to the second and third keynote session of the Maritime Research on Innovation, Environment, Science and Tradition International Conference, or MARINESTIC. My name is Elsa, and I am honored to serve as the moderator for these two keynote sessions. It is truly a privilege to be part of this meaningful event that gathers researchers, educators, and professionals who share the same vision: advancing maritime research through innovation, environmental awareness, science, and tradition. In these two keynote sessions, we are delighted to learn from distinguished experts representing both material science and language education, each offering valuable insight into how knowledge, technology, and communication drive sustainable maritime development. Let us begin with our second keynote session. Today, we are privileged to have with us a distinguished scholar and researcher from University Teknologi UMRAH, Negeri 9 Branch, Dr. Ahmad Hussaini Muhammad. Good morning, Dr. Ahmad.
Good morning.
Dr. Ahmad Hussaini Muhammad is a senior lecturer in chemistry whose expertise spans polymer chemistry, materials and nanotechnology, and analytical chemistry, particularly in simulation science. He has been with UITM since 2015 and currently serves as coordinator of the writing and publication section under the PGIM and A division, as well as an editor for the Malaysian Journal of Analytical Sciences. Dr. Ahmad extend beyond academia. He is also a lead assessor under the Skill Akreditasi Makmal Malaysia with the Department of Standards Malaysia, Ministry of International Trade and Industry. His experience and leadership in quality system, environmental management, and laboratory accreditation have positioned him as an expert in scientific and industrial standards. Dr. Ahmad obtained his PhD in separation chemistry from the Advanced Medical and Dental Institute, Universitas Sains Malaysia, and has published extensively in reputable Q1 and Q2 Scopus Index journals, including Talanta, TRAC Trends in Analytical Chemistry, and Microchemical Journal. He is also actively involved in multiple research grants, both as principal investigator and research collaborator, focusing on topics such as eco-friendly nanomaterials, deep eutectic solvents, and environmental pollutant remediation. Among his notable ongoing project is a fundamental research grant on molecular interaction mechanism of deep eutectic solvent-based magnetic cyclodextrin polymers toward cancer-causing bisphenols, reflecting his deep commitment to sustainability and public health. With this impressive background and deep scientific contribution, we are indeed fortunate to have Dr. Ahmad with us today. So today he will deliver his topic entitled Functionalizing Materials Using Deep Eustastic Solvents, a Path Towards Sustainability. Dr. Ahmad will have approximately 30 minutes to deliver his presentation. Ladies and gentlemen, please join me in welcoming our keynote speaker, Dr. Ahmad Hussaini Muhammad, to deliver his presentation. Dr. Ahmad, the floor is yours. Thank you.
Okay, thank you very much to Madam MC for the warm welcoming, and also thank you to everyone for your inviting me to this session as a keynote speaker. So as mentioned by the Madam MC, so my name is Ahmad Hussaini bin Muhammad. So actually I'm working with my current office is University Teknologi MARINESTIC, specifically at School of Chemistry and Environment, and my specialization in advanced materials and also analytical chemistry, which more focusedly in determination of contamination. Okay, so for first thing, before I proceed, let me read some of the pantun, okay, for the beginning. So melati kuntum tumbuh melata, sayang merbah di pohon cemara. Assalamualaikum mulanya kata, saya sembah pembuka bicara. With that, I will continue with my speech entitled Functionalizing Material Using Deep Eutectic Solvent, a Path Towards Sustainability. So deep eutectic solvent is a new kind of green solvent that has been developed around the world for today. Okay, so the content will be the milestone, the content of this today's speech will be the milestone of history dash, which cover the definition of the deep eutectic solvent. We also call them as a DAS, it's an acronym name. Secondly, the category of the deep eutectic solvent, the SWOT analysis for DAS to act as a green aspect solvent, the synthesis strategy, and why we need use DAS as a functionalization.
Excuse me, Dr. Ahmad.
Sorry?
Would you like to share your presentation material, or should we share from this side?
Oh, okay, sorry. Because I already share my material, so can you see my material?
Not yet. It is
Okay, can you
processing
see?
now. Yeah, thank you. You can go on.
Okay, so you can see my slide in full screen mode.
Yes, we are able to see it now.
Okay, thank you. Okay, so before I proceed, so let me introduce to my university. So given the name as a University Teknologi MARINESTIC, so our acronym as a UITM. So we have 34 campus around Malaysia, including Sabah and Sarawak. From the Borneo Island, we have the peninsula part, and also from the Sabah and Sarawak, which is near to the Kalimantan. Okay, so we have 34 campuses, which is 12 is an autonomous campus, 21 as a satellite campus, and 1 as a main campus in Selangor. Okay, in terms of UITM, in the Asian ranking level, we are in number 101, which is among 10% top university in Asian, and we are in the level of 542 in QS ranking world ranking. Okay, in my place, I'm working in one of the state which is we call Negeri Sembilan, and in Negeri Sembilan we have 3 campuses, which is Kuala Pilah campus, Seremban, and also Rembau. Okay, in my location, I work at Kuala Pilah. Okay, I work at Kuala Pilah, and then under the Faculty of Applied Sciences, which is specifically for School of Chemistry and Environment, which is we focus more on the chemistry part in terms of synthesis, analysis, and so on, including teaching and learning. Okay, so this is my colleague. We have around 26 staff under the School of Chemistry, which cover various fields from analytical, organic, inorganic, physical, and also polymer. So I will post as a polymer chemistry lecturer under the School of Chemistry. Okay, so we begin with the history of the DAS. Okay, so now we'll talk about the deep eutectic solvent. As we all know, in preparing material, synthesis, and everything, we commonly use solvent, which is acetonitrile, dichloromethane, ethanol, hexane, and so on as a chemist. But nowadays, due to the issue of the hazard and also toxic, scientists start to find a new way to prepare a green solvent. And one of the green solvent that has popularized by them is a deep eutectic solvent. Okay, so the concept of the deep eutectic solvent has evolved rapidly, okay, for the past 2 decades, and it's originally from the main parent, which is ionic liquid. So that's compared to ionic liquid is more cheaper, safer, and also biodegradable alternative. And the earliest generation involves simpler combination of 2 chemicals, which is choline chloride and also urea, which is the combination of during synthesis this product, it combined through hydrogen interaction. So since then, this field of synthesis has evolved, and it'll cover the natural deep eutectic solvent, which derive from the biological molecules such as amino acid, sugar, and organic acid. And it also moved to the bigger structure, which also known as a supramolecular DAS. Okay, so what are the deep eutectic solvent? It's a combination by mixing 2 or more hydrogen bond donor. We have 1 hydrogen bond donor, and another one we have a hydrogen bond acceptor, and we mix at certain molecular ratio in a state that we call a eutectic mixture. Okay, so this interaction result in significant dispersion of a melting point, producing a liquid phase that is stable at room temperature. So the strength of the deep eutectic solvent commonly lies at the interaction of hydrogen bonding between the hydrogen bond donor as well with the hydrogen bond acceptor. So this molecular handshake bind the component together, and the network create unique microenvironment capable of dissolving a wide range of chemical substances, from organic molecule to inorganic salt, including polymers. So the eutectic itself comes from the eutectic terms from the ancient Greek, which is eutectos, which means easily melted, and a eutectic point represents a chemical composition and temperature at which a mixture of 2 solids become fully molten at the lowest melting point, which relative to the either compound. So this cause a fitting description for this low melting and also high potential solvent to replace the common solvent that we currently use now. As for the category, scientists has categorized the solvent, this kind of solvent, based on the composition and its chemistry. So common cation, including ammonium, phosphonium, and sulfonium salt, while the hydrogen bond donor can range from the carboxylic acid, alcohol, urea, and also sugar. Okay, so we have 2 combinations, which is hydrogen bond acceptor and also hydrogen bond donor. we mix these two chemical, and the formation of hydrogen bonding will form a mixture solvent called deep eutectic solvent. There is a 5 types of category DAS, which is type 1, type 2, type 3, 4, and 5. After we mix between the hydrogen bond donor and also hydrogen bond acceptor. Okay, so for example, type 1, quaternary ammonium will mix with the metal halide. And then for type 2, we use quaternary ammonium salt with hydrated metal halide and so on. By changing this component, we can also tune the polarity. Either it can be less polar or more polar or semi-polar. And then in terms of its viscosity and solvation properties of the DAS that we produce. This tunability gives opportunity to the researcher to tailor-make the versatility into the chemical engineering, processing, and modification of the material after this. Okay, according to the SWOT analysis that has been conducted for DAS as a green aspect solvent, because we denote the DAS as a green solvent, so what are the properties, strength, weakness, threat, and also opportunity that we can gather from this preparing new kind of solvent? When we evaluate DAS using SWOT method, several key points emerge from here, which is their strength lies within their unlimited combination between the hydrogen bond donor chemical and also hydrogen bond acceptor, which made this chemical solvent can be tailor-made and tunable. Secondly, it's a biodegradable compound and can be recycled for next and also for reproducibility as a second generation types of solvent. This DAS consists of low vapor pressure and non-flammability, and also it acts as a thermostable, and in terms of economic value, it's a very economic to prepare this kind of solvent. However, in terms of weakness, we have the positive and also the negative side, but we more focus on the positive side. If you talk about the weakness of the DAS, in terms of selection method for task-specific DAS is very low currently compared to ionic liquid, and the raw material that can be used are still under investigation, and some of the mixture ratio will give you a high viscosity. In terms of threat, the scarcity of the toxicology data still underdeveloped, still in the process of developed by the researcher, and it will have an aggressive patent strategy. Okay, what opportunity can be obtained, which is in terms of large-scale industrial application, we can replace the common solvent by tailoring the mixture of the component, and then we can produce either we wish to have a polar or non-polar solvent that can replicate the properties of the current common solvent that we use in our laboratory. In terms of innovative, we can have many opportunity if we understand the whole concept of the combination and the strategy, synthesis strategy, how to synthesize this material. Okay, in terms of synthesis strategy, there should be a thoughtful during customizing the physical and also chemical characteristic of the deep eutectic solvent. First thing first, we need to consider the types of hydrogen bonding that will be used and types of hydrogen bond donor that will be paired with our hydrogen bond acceptor. Okay. Secondly, you need to understand the molar ratio that you need to include between the HBA and also HBD. And you need also to have a precaution method how to minimize the content of water. Next, in order for you to understand, so because this solvent is a tailor-made solvent, Okay, so normally we use this solvent once we understand the whole concept of the interaction, whether we wish to have a hydrophobic or hydrophilic interaction. Basically, this kind of solvent has been used in various analytical study to have a tailor-made activity and also interaction with a targeted analyte that we use to treat the environment and so on. In terms of processing the DAS, so there is many options that can be used. For example, we have heating and stirring activity. Next, we also can grind. We also can apply freeze drying method, and as well as we can select the vacuum evaporation strategy method. Additionally, you can also take into consideration the conductivity as well as the structure, stability, solubility, viscosity, and whatever desired application that you need to pair off with your final application. Okay, so this is the strategy that almost every researcher they use in order for them to prepare this kind of solvent, so that the ultimate solvent that produced after this will match with the target desired application that they wish to improvise. Okay, so what are the benefits that we use DAS for the functionalization? By altering the hydrogen bond acceptor and also hydrogen bond donor components, DAS polarity, viscosity, and reactivity can be tailored. DAS actually are particularly valuable because of their physical chemical properties, such as I mentioned, polarity and viscosity, which is we can tuning to whatever the interest that we need. Secondly, they can participate, they can offer you with multiple types of interaction that can interact with your next application, such as hydrogen bonding, pi stacking, ionic interaction, and so on. Besides that, during the functionalization, the preparation is very feasible. We can conduct either in situ or ex situ, and we can also use one-pot synthesis method, which is more practical, and we can produce our target functional group on our targeted material. So this DAS normally has been used to dissolve many kinds of chemicals, which is a cover from a wide range of organic, inorganic, and also polymeric material, which is currently cannot be conducted or performed by the common solvent. And last part, in terms of DAS for functionalization activity, it also offers a sustainable replacement for harmful organic solvent, and also it can replace, because last time we used ionic liquid and its polymeric version, and it has been reported that this ionic liquid also suffer from the toxicity, and they produce a new kind generation of solvent to replace this kind of ionic liquid, and DAS can offer better compared to ionic liquid in terms of degradability, toxicity, and also volatility. So this is some of the several case study. I put around the three case study that has been using DAS as a modification material on the as a modification material. First is a modification of cellulose using deep eutectic solvent. In this study, they use choline chloride and also lactic acid as a hydrogen bond donor and also hydrogen bond acceptor, which is after pre-treatment of this cellulose, the DAS swell the structure fibers of the cellulose, and it can fibrilize until it get the nanoparticle size. Okay, so the surface modification and also grafting of cellulose nanofiber also were conducted using the one-pot strategy using the DAS system, which is composed of lactic acid and also choline chloride. and also lactic acid, choline chloride, coprolactone as an additional functional group. This presence of the polylactic acid and also polycoprolactam change on the cellulose nanofiber significantly will enhance, and also the utilization of DAS increase the dispersibility of the modified cellulose material in hydrophobic polymer matrices. Okay. So for the next modification that I use as a sample study, so this is done by my colleague at the USM. So this has been published in Q2 journal, and then he used a urea-based deep eutectic solvent, which is composed of urea and also ethylene glycol. And this was employed as a functionalization agent to modify the graphene oxide, the surface of the graphene oxide. And then he obtained this modification on the magnetic graphene oxide surface with estimated content 90.14 weight percentage. So the resulting modified version of magnetic graphene oxide is they promote the enhancement of hydrogen bonding interaction, which is attributed to the oxygen and nitrogen containing functional group due to the presence functional group from the DAS itself, and its offer absorption mechanism towards the target analyte by offering multiple kind of interaction, for example, hydrophobic interaction, pi stacking, hydrogen bonding, and also van der Waals forces. So the last part, which is we use also DAS as a functional monomer in preparing for preparing MIP. Okay, so MIP is a types of polymer that we tailor-made to have a cavity that have similar with our target analyte. So as a molecular imprinted type, so the use of this green DAS and a water that employ as a functional monomer and corrosion will help improve the synthesis of MIP, and then the interaction that they can form is the DAS will provide the cavity that's similar to the target analyte that has been used in this topic, which is bisphenol, and then they form multiple interaction. For example, it provides hydrogen bonding, pi-pi interaction, as well as it minimizes the water interference between the molecules. Based on the calculation absorption, it offers a model of pseudo second order, which is it's aligned experiment with a absorption capacity more than 40% within 60 minutes. So this kind of development polymer demonstrate a good regeneration, and also maintain its recyclability activity. Okay, so for the conclusion, so the use of DAS in material functionalization, normally they present a promising and also sustainable alternative to the conventional solvent that currently being used right now. So their tunable physical chemical property that can obtain, as well as their low toxicity, biodegradability, and also ability to facilitate multiple interaction has made this new kind of solvent as an idea to be applied as a modified agent for a wide range of material, which include various kind of chemical component, including nanomaterial, polymer, and also bio-based substrate. So by enabling the surface material during modification under this mild condition, we expect that the deep eutectic solvent not only enhance material perform in various application. So for current project that I involve, normally I'll obtain the grant in this DAS formulation, which I conduct a surface modification on the cyclodextrin, which is glyceride, carbohydrate types of polymers. Okay, so we modified and we use as absorbent, natural absorbent, to treat it, to remove the bisphenol component, and also we expand the activity also on PFAS. By using this kind of solvent, we expect we can produce more interaction and we can obtain such a wonderful performance that can be offered, and also it can be recycled more than what current solvent that can perform. So that's all. So for collaboration after this, you can email or send an email to me to my personal email or my office email, as I showed you earlier. And this is my address if you wish to have a collaboration and so on. So thank you very much.
Thank you very much, Dr. Ahmad, for your insightful and inspiring presentation. So, ladies and gentlemen, I'm sure we all gain valuable perspective from this session. As we were following a tight schedule, the Q&A session for this keynote will be held together with the next keynote speaker session. So we kindly ask Dr. Ahmad and our virtual audience to stay online with us. The discussion and question will be addressed right after the next presentation. Once again, thank you, Dr. Hussaini, for your wonderful sharing.
Thank you very much.
I just want to make sure for our team whether the next speaker already joined in our virtual room. Yeah, to Dr. Christian Adiputra, our next keynote speaker. Do you already join us? Yeah.
Yes, I'm here.
Yeah.
Yes, I can hear you clearly. Thank you.
Yeah, thank you, Doctor. Ladies and gentlemen, we now move forward to our third keynote session. It is my great pleasure to introduce our third keynote speaker, Dr. Christian Adiputra, Assistant Professor of English and Coordinator of the English Language Testing and Assessment Unit at Prince Satam bin Abdul Aziz University, Kingdom of Saudi Arabia. Dr. Putra earned his PhD in Second Language Acquisition and Teaching and his Master of Arts in English Applied Linguistics from University of Arizona, USA, both with excellent academic distinction. His research interests including language policy and planning, teacher education, multilingualism and linguistic landscapes, and he has extensive teaching and research experience in Indonesia, the United States, and Saudi Arabia. Dr. Putra is also an active scholar and keynote speaker in international conferences with numerous publications focusing on applied linguistics, technology integration, and English for specific purposes. Today, Dr. Putra will deliver his material entitled English for Maritime Purposes through Applied Learning Approaches, Theory, Policy, and Practice. Dr. Putra, you will have approximately 30 minutes to deliver your presentation. So, ladies and gentlemen, both on-site and online, please join me in warmly welcoming Dr. Christian Adiputra. Yeah, Dr. Putra, the floor is yours.
Thank you. Thank you so much for the warm introductions. Let me share my screen. Okay. So, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. Hello from Riyadh, Saudi Arabia. I'm really honored with the opportunity to deliver a keynote speech at MARINESTIC 2025 today, organized by the College of Education of Universitas Maritim Raja Ali Haji. Today, I'm going to talk about English for maritime purposes through applied learning approaches from the perspective of theory, policy, and practice. The same with the previous speaker. Let me begin with a pantun. I think you are familiar with this place. Ngopi-ngopi di samanku selepas kerja. Hilang penat, badan segar, hati pun ceria. Bapak Ibu yang hadir di Dompak sana, izinkan kami nak berbual-bual sekejap aja. So, Tanjung Pinang has been my home since 2016. My wife is from Tanjung Pinang, and my parents-in-law also still live there. Every year, I'm also in Tanjung Pinang, enjoying my summer vacation with my family. So, as in the slogan of the city, Tanjung Pinang, kampung kita juga. I will begin my talk by discussing the theoretical perspective of ESP. After that, I will continue with the discussion on the overview of the policy of the teaching of ESP, and then English for maritime purposes for EMP, and then applied learning approaches in the teaching of EMP, and finally on the pedagogical framework and classroom implementations of the teaching of EMP using applied learning approaches. My talk today is inspired by the fact that global job opportunities and the interconnectedness of the global economy have increased the demand for English language skills for both daily and professional communication, known as English for general purposes and English for specific purposes or ESP. This has resulted in the development of various branches of ESP, such as English for academic purposes, English for vocational purposes, and English for occupational purposes. As it shows in the name, EAP is for students to succeed in their study. EVP is for students who are preparing to enter the job market, and then EOP is for professional in the workplace. Now let's discuss one by one. English for academic purposes is generally taught in English as a medium of instruction university programs and is aimed at equipping undergraduate and graduate students with the English language skill necessary for their studies. It trains students to listen to lecture and talks, participate in classroom discussion and presentation, read academic papers, and write academic essays and research reports. Therefore, EAP focuses on key skills such as academic listening, academic speaking, academic reading, and academic writing. English for vocational purposes is also taught at universities. This is also taught at UMRAH. It prepares students in vocational and technical education programs for real-world communication in their future workplace. EVP is closely related to student field of study. So for example, if students are studying in medical schools, then they will take English for medical professional, while engineering majors take English for engineers or other discipline-specific courses relevant to their future professions. Now, let's move on to English for occupational purposes or EOP. English for occupational purposes is commonly facilitated by companies or organizations. It helps their employees to have necessary English language skills relevant for their day-to-day responsibilities. Similar to EVP, it is relevant to employees' professional fields. So, if the students are lawyers, they might take English for legal purposes courses. So, how are ESP commonly taught universities? Let me start with the example from Saudi Arabia. While students are studying in Arabic at public schools, they study in English at public universities in Saudi Arabia. So if you study in Saudi Arabia, you will not use Arabic in the classroom, except if you are majoring in Arabic and Islamic studies. If you are majoring in business, engineering, or other majors, you will use English in the classroom. It creates challenges for universities and makes them establish intensive preparatory year program. Students study English for 2 semesters before beginning mainstream EMI programs in the 3rd semester. In semester 1, as you can see on the slide, they study reading and writing skills delivered in English. Other subjects are foundational courses still taught in Arabic. Then in semester 2, they study listening and speaking skills and an English for vocational purposes course. Other subjects in the 2nd semesters are also taught entirely in English using a content and language integrated learning approach, where lecturers teach key vocabulary, phrases, and expressions from the text before explaining the content of the materials. All these courses are taught intensively, 3 times a week for 100 minutes. Again, 3 times a week for 100 minutes, which is very, very intensive. They are also expected to reach lower intermediate level at the end of semester 1 before taking the EVP course and reach upper intermediate level at the end of semester 2 before beginning mainstream EMI program. Let me continue with the example from the United States. They focus on English for academic purposes. While most students are native speakers of English, as we all know, the language that they use for daily communication is different from academic discourse. So, the EAP course is aimed at helping students succeed in their study. Students study English Composition 101, 102, 103, and 104. While the focus is on academic writing, it's actually an integrated academic skills course. Students learn how to listen to lectures, discuss and present their papers, read research papers, and write assignments in English. Again, it's also taught intensively, 50 minutes a day, 4 times a week. Again, I will highlight this one. It's also taught intensively, 50 minutes a day, 4 times a week. Now, what about in Indonesia? It is typically taught over 2 semesters only. Semester 1 focuses on English for general purposes, or in Bahasa Indonesia, mata kuliah umum Bahasa Inggris. In semester 2, focuses on English for vocational purposes, or in Bahasa Indonesia, mata kuliah Bahasa Inggris profesi. They are taught once a week for 100 minutes over the course of 16 meetings. Interestingly, in semester 8, students are required to take the TOEFL-like test as a requirement for graduation, an indication of their English language proficiency. Some lecturers are also tempted to teach TOEFL instead of relevant English for general purposes and English for vocational purposes materials because of this TOEFL test policy. So, there are still some problems to highlight. First, The learning outcome is still unclear. Is it to help students to reach an upper intermediate or advanced level of proficiency in English? Is it to help students use English in daily and professional contexts? If it is aimed to do so, students are not really placed based on their levels of English proficiency, and classes are not really designed to be intensive. EVP is also taught without considering student level of English proficiency. Therefore, it might also be hard to know the success of the programs and whether or not students reach the upper intermediate level before beginning the EVP course. Theoretically, in theory, students need to reach at least upper intermediate level before they study English for vocational purposes. Imagine, they are still struggling with basic English vocabulary for introduction. My name is, I am from, I am majoring in, and blah, blah, blah. And then we ask them to learn complicated medical English vocabulary, such as anatomy, surgery. It will be a big problem for the student. So they need to reach at least upper intermediate level or advanced level before beginning to study English for specific purposes, or in this context, English for vocational purposes or English for maritime purposes. Now let me continue. So how should ESP ideally be taught in Indonesian universities? Let me clarify, and let's take a look at an example of the teaching of foreign languages from American universities. Undergraduate students in the United States are required to learn one foreign language as a requirement for graduation. They can choose any foreign languages taught at the university, such as Arabic, French, German, Korean, Spanish, among many others. They study the language for 4 semesters. For example, Spanish 101 in semester 1, Spanish 102 in semester 2, Spanish 103 in semester 3, and then Spanish 104 in semester 4. They are leveled from beginner to advanced. So semester 1 beginner, semester 2 lower intermediate, semester 3 upper intermediate, and then semester 4 advanced level. In semester 5, after reaching an advanced level, they can optionally take 105, which is equivalent to English for specific purposes course. They are taught again intensively, not just 100 minutes a week, and required to graduate with an advanced level in their chosen foreign language. So, if we follow this model, we can offer EGP and EVP in 4 semesters. They should be taught intensively, not just 100 minutes a week. They should also be leveled from beginner to advanced. In semester 4, students study English for vocational purposes. Therefore, it follows the theory of ESP courses. It follows the theory that ESP courses can be taken after students reach an upper intermediate or advanced level of English proficiency. To do so, students will graduate with an advanced level of English proficiency and will be able to use English in daily and professional communication. Now, let's move on to English for maritime purposes, or I will call it EMP. EMP is a specialist branch of ESP that focuses on equipping maritime professionals with the specific language skills needed for navigation, vessel operation, and maritime industry communication, among others. There are some major focus areas of EMP courses, such as maritime industry, maritime navigation and safety communication until maritime tourism, as you can see on the slide. So English for maritime purposes, or EMP, is important as it equips future professionals in the maritime industry with specific English language skills required for their day-to-day responsibilities. So if we take a look at the locations of the province of Riau Islands or Kepulauan Riau, the province of Riau Island is located in the strategic maritime region, which make it has all these contexts, beginning from the maritime industry to the maritime environmental management, where the EMP course is needed. University students in the province of Riau Islands or Kepulauan Riau need to be equipped not only with EGP or English for general purposes and English for specific purposes relevant to their majors, but also with EMP or English for maritime purposes to meet the communication demands of the regional and global maritime sectors in the region. Now, let me connect it with applied learning approach. What is an applied learning approach? Why is it relevant for EMP in UMRAH, for example? I'm really interested in this approach after I read the descriptions of the ESP course taught at Singapore Institute of Technology. They are using applied learning approach. What is an applied learning approach and why is it relevant for EMP? An applied learning approach is a pedagogical model that connects classroom-based instruction with authentic and real-world practice. It emphasizes learning by doing, where students apply theoretical knowledge in practical, professional, and context-specific tasks. Theoretically, it centers around experiential learning, constructivism, work-integrated learning, and task-based language teaching and learning. So the applied learning approach situates English language instruction within authentic maritime contexts, guided by experiential and constructivist learning theories. Its key features: authenticity, integration, collaboration, and reflection ensure that learners develop both linguistic competence and professional readiness for the global maritime industry. So, if we are using applied learning approach, there will be a link and match between universities and the maritime industries. The industries inform universities about how English is used in real maritime contexts, and that's a very important point. The industries provide feedback on the curriculum and syllabus. The industries provide authentic materials and case studies. The industries facilitate students experience workplace communication through internship and site visits. The industries participate in teaching and assessment. So they can be invited as guest lecturers in the class and tell the students about how English is used in the industry, for example. The industries support professional development for lecturers. And finally, the industries collaborate in research and innovation with the lecturer. Now, if we take a look at my proposed pedagogical framework here, universities, industries, and students work in a reciprocal partnership where classroom learning, industry input, and real-world practice support one another. University plays a role in teaching, industries in facilitating learning, and students learn from both the lecturers at the university and professionals in the industries. University prepares the curriculum, syllabus, and assessment, while industries facilitates internships, materials, and feedback, and students practice using the language in simulated or real-world professional contexts. So, applied learning approaches require universities and lecturers to involve maritime industries throughout entire teaching and learning process to make learning more authentic, relevant, and connected to real-world professional contexts. It begins with needs analysis and the formulation of relevant learning outcomes. What do students really need? What do the regions really need? In Bali, for example, English for tourism needs emphasis, as the tourism industry in Bali is growing rapidly. But then in Tanjung Pinang, we need to carefully analyze and look for the priority of English for the maritime purposes to teach to our students. The collaboration with the industries continues with the curriculum and syllabus design, materials development and adaptation, methodology and classroom practices, assessment and evaluation, and teacher reflection and professional development. Let me clarify further that we need to develop, adapt, and adopt the available teaching materials we might find somewhere else. What an EMP lecturer in Europe develops, or what an EMP lecturers in the United States develop, might not be relevant for our context. Therefore, it needs to be made relevant. There is a need to understand what learners really need in the EMP course in the Riau Islands or Kepulauan Riau context through a comprehensive needs analysis. The result of this needs analysis should serve as the basis for the development of learning outcomes and the design of syllabus. Teaching materials must then be developed, adapted, or adopted in alignment with these learning outcomes to ensure the relevance, authenticity, and effectiveness in meeting learners' communicative and professional needs. So, what EMP teaching policies can be suggested? English can be offered in 5 semesters, where semester 1, 2, and 3 focuses on English for general purposes. It begins from beginner level to intermediate level to advanced level. And then in semester 4, it focuses on English for specific purposes relevant to the student majors. So if they are studying in law, then they are going to study English for legal purposes. If they are studying in business, then this is business English. If they are studying in engineering, then it is English for engineers. And then in semester 5, it can be focused on English for maritime purposes. All these courses need to be taught intensively. It helps students achieve the advanced level of English language proficiency, then continue with English relevant for their professional job, and finally with relevant English for maritime purposes needed by the region. Finally, what can we conclude? First, it is important to integrate English for general purposes or EGP, English for specific purposes or ESP, and English for maritime purposes or EMP to equip students with English language skill used for daily communication, professional context relevant with their majors, and also for the maritime industry. Second, the teaching of EGP, ESP, and EMP must be designed to be intensive, structured by levels from beginner, intermediate to advanced, and aim at enabling students to communicate effectively in English for both daily and professional contexts. Third, an applied learning approach is relevant for EMP as it ensures that students get hands-on experience and industry-relevant practical skills. Finally, university and industry partnership ensure the relevance of the courses, and prepares graduates ready for the maritime industry. Let me end my talk with another pantun. Hari Jumat pergi ke Dompak, mampir sholat di Masjid Raya Nur Ilahi. Kalaulah ada salah yang nampak, awak mohon maaf tulus dari dalam hati. Thank you so much everybody. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Putra, for your insightful presentation. Your discussion on the integration of applied learning in English for maritime purposes, CSP, and EAP has truly broadened our understanding of how language education can empower maritime professionals and connect theory with real-world practice. So we will now open the floor for a short question and answer session for both speakers. To our on-site participants, please feel free to raise your hand if you'd like to ask a question. And kindly state your name and affiliation before asking. And for our online participants, you might type your question in the chat box and I'll read one or two aloud for our speaker to respond. So let's begin question from the floor. Anyone from the audience, please? Yeah, all right. While our audience is gathering their thought, perhaps I could start one question for Dr. Christian. Dr. Christian, you explained that maritime English requires a more applied and authentic learning process. Could you share some examples of classroom activities or tasks that can really help students experience the real communication demands they might face at sea or in port operation? And also, do you think that English EMP should be taught by English lecturer or by subject matter expert trained, especially for ESP? Yeah, Dr. Christian, please.
Thank you for the questions. I will begin with an example of a very interesting story of my students in Solo, Surakarta. One day, he told me that one of his students just finished doing the internships in a pharmacy in Surakarta. And then the student actually studied in vocational school, SMK, in Surakarta. And then the student complained to the teacher. In the pharmacy, I met someone from the US. Someone from well, basically Australia, US, or Europe. I don't really remember the details. And then the student said, but then I couldn't really explain to the person or to the customer of the pharmacy whenever he want to buy something there. The English that you are teaching is not the English that I need in the professional job, in the professional context, which is very interesting. And then I asked my students, what are you teaching in your class, by the way? And then he said, general English. It's general topics, but they're not specified to the English for pharmacy. So this is kind of interesting because in SMK and also universities, there are a lot of cases where the materials taught to the students are not relevant. They are still general. So whenever they go to their professional context, they find it hard to use the language. For example, if I relate to your question, in the case of this student, for example, English for pharmacy, of course, they need to study about let's say let's say a certain thing about the medicine. So, for example, if they are playing role play, they need to be a pharmacist, and then some students play a role as the customers, and then customers can ask, I have this problem, and then I want to buy a medicine for my problem. And then the pharmacist can answer very well about the medicine that the customers need. And then the pharmacist can also explain about the dosage, and then the what is the what what the medicine contains and everything like that, including some other kinds of questions related to prescriptions, and then have you seen the doctor and things like that. And then in the context of my students, the student did not really study about that. So role play activities, as it can be seen in a pharmacy, can be done also in the classrooms. And then it also includes, for example, if the students are studying English for legal purposes, for example, they can also study how to write a certain legal letters. If they study, let's say, uh, uh, English for maritime purposes, and then let's say, let me give another example. Let's say English for engineering, for example, and then they can explain, for example, because in my context, the students are studying English for engineers and also English for medical professionals. They can draw a picture of let's say anatomy of someone's body, and then they focus on what is that? I forgot. A certain system, urinary system, for example, and then they can draw a poster and then explain, and this one is the name of this human body is this, the name of this human body is this, and then they can explain it. So that can be done in the classroom, role play, and then presentations, and then writing, and then well, definitely it integrates all language skills: presentation, which is speaking, and then writing, and then reading legal letters, and then interpret it, and then explain about it, and then after that responding to legal letters and things like that. So basically, the activities that needs to be developed in the classroom is something that they will also do in the professional context. So that is why we need feedback from industry professionals. After we are developing the syllabus and curriculum, we need to consult to them. Is it relevant with what you need in the professional context? Is it what you see every day? If it is not, then probably we need to revise it because this is not relevant. Maybe that's my answer.
Yeah.
I hope it answers this question.
Thank you, Dr. Christian. If I could go back to your slide presentation, the book that you recommend in your slide. I believe I ever used that kind of book, English for Maritime, for students majoring ship engineering, teknik perkapalan. So yes, we use that book in my classroom, but personally I find it difficult to teach English based on that book. So I think you need to answer this one. Do you think English for maritime purposes should be taught by English lecturer, or do we need to hire the professional that really focus on the subject matter? For example, for the students majoring ship engineering, so the English for them is the expert who really know the field.
Interesting. Well, in Indonesia, in some universities in Indonesia, as I know, I have seen that they are taught both by the lecturers of English as well as the lecturers in the study program who have the background of learning. So let's say, I will tell you about the context in Universitas 11 Maret where I have ever taught there. Some lecturers teaching English in the College of Law, they are the lecturers in the department. And then usually they got their master's degree and also PhD in the US, in the Europe, and also in Australia, so that their English was very good. And then they know the contents of the materials and things like that. But then at one point they said we need collaboration with English lecturers. So English lecturers focuses on the teaching of English for general purposes, and then English for vocational purposes at the time was taught by the lecturers of law from the Department of Law. So there is a collaboration there. But then there are also examples where English for vocational purposes are taught by English lecturers. If that is the case, then of course, as I mentioned in my slide, there is a need for lecturers of English to update or to upgrade or to relearn or to learn more about the things that they are teaching. In my context, for example, in Saudi Arabia, I'm teaching English for medical professionals and also English for engineers courses. And it takes time for me. I spend the whole summer to study the new vocabulary and all the things that I need to teach to my students. And then it's really interesting because to me it's totally different. My background is not engineering. My background is not medicine, but then I'm required to teach the courses. So if that is the case, then the university also needs to facilitate teacher professional development sessions where some professionals from from the industries, as in the case of UMRAH, then it's from the maritime industries, they need to be invited to provide updates about the things that they are doing in their professional context. Therefore, they can give you updates about those things, and then you can really make it relevant for your students. And yes, I want to say that it's fine for us and it's a challenge for us because wherever it is, even in Singapore Institute of Technology, they are offering English for vocational purposes and they are taught by the lecturers of English, and their backgrounds are in second language acquisition, TESOL, applied linguistics, and they are teaching English for engineers, English for technology specialists, and things like that. And definitely, it becomes a challenge for them. And then what I want to say, the university needs to facilitate the teacher professional development session, and then the lecturers themselves need to take some time to take a look at the materials and learn. I don't want to say give the job to the lecturers in the department. It can be our job too, but then it becomes a challenge for us. Maybe that's my answer.
Yeah, thank you, Dr. Christian. That gives me a lot to think about, especially for teacher and curriculum developers. Okay, now, what about the audience? Is there anyone to ask? Yeah, yes, please. So, the question from? Yeah, kindly mention your name and your affiliation and where your question goes to.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Yeah, let me introduce myself first. My name is Wisudawati Amelia Putri. I'm from the English Language Education Study Program. First of all, I'd like to express my gratitude to Mr. Christian Adiputra for delivering such an interesting material about English for maritime purposes through applied learning approaches. And I'd like to ask a question. What are the current trends and the future direction ESP research and pedagogy. I asked this question because I wanted to understand how ESP teaching and research are developing in recent years and what direction they might take in the future. Thank you.
Yeah, the question goes to Dr. Christian. Dr. Christian, would you like to respond now?
Interesting. So thank you for the questions. That's very interesting questions. I have seen a lot of examples. For example, in Saudi Arabia, we are doing a lot of research on globalization. So globalizations mean global and local. So at some points, we are teaching a lot of for example, global what's that? Global values and global culture in our English language class. But then at the same time, we also need to consider whether or not they are relevant with our context. In the context of Saudi Arabia, the things that we are teaching to our students need to be relevant with the Islamic values, with the Arab values, with the Arab life principle. So that is why a lot of times whenever we are teaching in the classrooms, we need to integrate a lot of Islamic values. For example, we start with Assalamualaikum, how are you? And then Alhamdulillah. So things like that. And then there are a lot of examples where, for example, in the textbook, we don't include the pictures of, what's that? The pictures of women without hijab, and then the picture of something that is not relevant with or aligned with Islamic values and principles. And if I relate to your questions, there are a lot of things that we are doing in Indonesia. For example, we still need to do a study highlighting the policy of the teaching of ASP, because a lot of time the policy that we are doing is not really relevant with what the students need, as I mentioned earlier. For example, is the TOEFL test really needed? For example, is the design of the teaching and learning in semester 1 and semester 2 strong enough to help students to achieve the goal of the teaching of ESP? So if I mentioned earlier, in semester 1 we are studying EAP, but then in many places in Indonesia, the students are not studying English for academic purposes, or the students are not studying English for general purposes. They are studying TOEFL skills tests, for example. They are studying reading skills, listening skills, speaking skills, and writing skills for the test. And that is why this is not relevant. So I think if you are doing research right now, you need to, you can do, for example, analysis or student perspective on the materials being taught to the students. Or if you are focusing on the lecturers, you can also ask the lecturers on the lecturer's perspective on the materials of EGP and ESP being taught to the students. And then after that, you can go from there. I mean, it can be an input for the universities in Indonesia about how the teaching of EAP and the teaching of ESP can be improved, including the materials, the syllabus, and also the focus as well as the policy. I think in Indonesia that is very possible, because there are still some problems that we can really explore and also improve compared to the example that we have seen, for example, in the Middle East, in the East Asia, as well as in the Northern America, for example. There are some examples that we are still, there are some cases that we are still in the wrong direction of the teaching of English in universities. We need to think again about how we do it better in the future, because students study in 100 minutes a week for 16 meetings. That's not going to be enough to make them able to speak English in daily communication and professional communication. We need to do it better. I think that's my my point and suggestion for research for you.
Thank you, Dr. Christian. Your explanation brings us to the end of the session. Thank you very much to our speakers and participants for the short but meaningful discussion. We truly appreciate your engagement and insights. So, ladies and gentlemen, that concludes our question and answer session. Once again, let's express our sincere appreciation to our keynote speaker, Dr. Christiana Diputra and Dr. Ahmad Husaini, for sharing their expertise and valuable insights. Thank you also to all participants for your thoughtful engagement. Now we will move to the next agenda of our conference. Assalamualaikum warahmatullahi wabarakatuh.
Bapak, Ibu, dan hadirin yang kami hormati. Selanjutnya kita akan masuk ke sesi pemaparan materi yang keempat dan tentunya akan dipandu oleh moderator kita, yakni Ibu Dr. Nana Raihana Askurnia, SPD, SH, MHum, secara virtual. Kepada Ibu, disilakan.
Next, we will now proceed to the fourth plenary session led by our moderator, Dr. Nana Raihana Askurnia, SPD SH MHum. To her, please welcome.
Thank you, the MC. Good morning, everybody. Assalamualaikum warahmatullahi wabarakatuh. We are in the next plenary session. I am Dr. Nana Raihana as your moderator. I would like to welcoming Dr. M. Reddy from Canada for being here, for participating. Yes, in MARINESTIC 2025. Before we go to the session, please let me read your CV. Dr. M. Feridi obtained his PhD in the area of material science and engineering from the University of Bordeaux, France, from July 2003 to May 2019. He worked at the Department of Materials Science and Engineering, Chemistry and Physics, National University of Singapore, June 2019 to August 2021. He had worked at the Center of Excellence in Transportation, Electrification, and Energy Storage, Hydro-Quebec, Canada. Currently working as a senior professional researcher and group leader in energy storage technology at Nouveau Monde Graphite, Quebec, Montreal, Canada. Dr. Reddy has published 220 papers in various international journals and land review paper published in chemical reviews, cited over 3,200 times. He has obtained an H index of 78 with over 2,900 stations. Dr. Reddy is serving as an editorial advisory board member in Materials Research Bulletin and Journal of Energy Storage, Elsevier Scopus Journal, Journal of Solid State Electrochemistry, as well as several open access journals. He also received several awards: Outstanding Science Mentorship Award, Inspiring Research Mentor Award, and Battery Materials Electrochemistry Award from the Electrochemical Society of India, Indian Institute of Science. Okay, Dr. M. Feridi, this session will be divided into two. The first session is 20 minutes for you to do presentation and explanation, and the next is 10 minutes for question and answer. Okay, Dr. M. Feridi, the time is yours.
Okay, thank you, Chairman, for your kind words. I would like to know that my slide is moving. You're able to see second slide? You're able to see the second slide? Yes, madam? You're able to hear my voice? Hello?
Yes. Okay, the
the slide
person who is in charge, please help Mr. Reddy to do his slide, please.
Okay, okay. I'm going to start again. Salam alaikum and all my Indonesian friends. Okay, in fact, this is my conference I'm giving in the online. In fact, sorry, I'm not able to present in person. In fact, when I worked at National University of Singapore, I visited different places, including Surakarta and Ambon and different type of the, including ITP, etc. So maybe future I would like to visit in person. So I saw the conference. In fact, this conference has been attracted distinguished guests. People are talking about what is the importance of maritime industry and the people's importance of mathematics, what is the importance of language, especially English language is really very important. Not any language, for example, I based in Quebec, where in this province is speaking French, so that at least I have to in my work I have to speak in French. Although whole Canada is in English, like all the provinces, especially this particular province, we are speaking French. So at least that is I think speaking language is very very important. And especially the English is very very important for all over the people because it is a common language. Write a publication irrespective of any science and engineering, mathematics, etc. So without any further delay, and again, thanks to all organizers for putting this conference, including the session chairs, etc., the hard work. So without any further delay, so I can previously I was at Singapore, and then especially in Canada, we can see different type of seasons. So as you can see clearly, what is the importance of nature, etc., the climate, etc. So without any further delay, since they've given me 20 minutes, I quickly I'll go through what are the importance of materials and followed by the sustainability, etc. Since many young researchers are, I'm telling that the research is no boundary. Anybody can do research. These are a few examples. I've been trained at various high school and junior college students at National University of Singapore. So they're presented at the various conferences held in Singapore and outside also. Again, I think collaboration is very, very important. I think when I was at Singapore, I've been invited a lot of Indonesian distinguished Indonesian researchers to my laboratory and some outreach also we have done. And then again, I think these are a few researchers we have been trying to take. As you can see clearly, Indonesia, we have been already I published some joint papers with the various universities, including that Bandung, Padijaran, and University of Indonesia, Manado, and Surakarta, including that few other places like Patimura. It clearly shows that so this research collaboration is very very important. So without any further delay, I think my talk is a general talk, so I don't have much time to discuss two details. So materials will play an important role if you talk about the basic sciences or applied sciences, or if you talk about engineering, if you go to mechanical or composite or metallurgical engineering, including your electronic engineering, etc., or engineering, electric, etc. As you can see that for today's talk, I think materials will play an important role. For example, silicon age is a one. I think without silicon age, I can't talk and I cannot interact because of the with the silicon is very important, including your eye or like miniaturized devices, including computer or internet, etc. I think silicon is one of the that age is really and composite material. As you can see, these materials are very useful. If you talk about any maritime industry, people are looking about the lightweight material, like very strong materials and corrosion resistant material is very so that is very very important for the maritime industry. So that's why people we have to understand the corrosion resist. For example, in sea there is salt water. The materials, the composite materials, it must be corrosion resistant. Again, I think always we are talking about the future intelligent material for low carbon age, etc. As you can see clearly, the materials will play an important role irrespective you talk about anywhere. So this we talk about construction materials, technology, or if you talk about electronic technology, for example, if people are working with solid state electronics or electronic engineering, you may use silicon, germanium, and energetic. And for example, if you talk about superalloys or steel, they are also used in the maritime industry, for example, ship construction, etc. They're doing a lightweight material, etc. Or sometimes they want to be stronger, corrosion resistant materials are needed. If you talk about the physical properties, I think the materials people are learning and understanding good physics. The optics is playing important role. People are interested in understanding the photonics or dielectric material. Today I'm going to talk about how the energy storage or nanomaterials or any materials that can use it for the various applications. At the end, information science play an important role. People want to be advanced modeling, predicting new materials for energy, environment, AI, automation, including mathematics. All the RG will play an important role in the understanding the information or mathematical model, etc. So again, these are a few examples. Again, the materials for the impact of steel and are like composite materials. Again, the material play an important role. As you can see that everywhere people are looking for the lightweight and corrosion resistant material in terms of the various technologies. If we talk about the optics, for example, again the people are looking about the materials for like it is again there's a lot of physical property, people a lot of physics, or if people can understand the laser physics, or if we talk about the glasses like that are also very useful. And again, if we talk about solar PV technology, again, so these are also very, very important. I think the people have to understand the what is the basic principle, or in terms of manufacturing, or understanding the physics and electrical engineering point also, how to store the energy. I think my previous speakers are talking about the materials for especially the thermoelectric applications. I think materials play an important role in the especially want the cool. In general, advanced materials are used in various applications, starting from photonics, spintronics, and clean energy, or photocatalysis, etc. Again, the healthcare and water technology, again, the materials play an important role. As you can see clearly, everywhere, for example, there is sensors, for example, atmospheric sensor or our body sensor, I think that will play an important role. So this is a summary. There is a lot of materials. People are, if we talk about the engineering, or if you want to be various aspects. So that's why the materials innovation is very, very important. Or for example, if you're predicting new material, AI, automation, I think that is very, very, very important. If you talk about the research also, materials play an important role. In general, people are talking about renewable energy. Again, it will that always people are should be low cost and need to be clean so that it won't pollute the things. So that's why, for example, place like Indonesia, there is huge amount of solar energy. I think that is the one with the viable option. Place like here, the water, that's why there is a lot of hydroelectric dams there. So again, for example, if you talk about any place like in Indonesia or India, Jakarta, or major cities, we may see the 40 to 50% of the pollution is from the with the vehicles, gasoline-based vehicles. I think people are looking about the replaced by gasoline by electric vehicles. So that's why the what we call as the batteries are one of the important devices. People are thinking that's why. So because that's why we need a raw materials. Again, in general, the energy and environmental science and engineering is a multidisciplinary. For example, we need to understand the physics, chemistry, mathematics, materials and mathematics. That's what we call as basic sciences, and mechanical, automobile, and chemical engineering. For example, if you want to be mining engineering, I think we need the chemical engineering. Or for example, you want to innovate, understand the what they call smart charging, etc. You have to understand the electrical engineering and information science. Or if you want to do mining engineering, I think we have to work with a civil engineer. Finally, the management. I think this is very, very important to run all this one. So again, I'm telling that it is always the university, the place where you're educating the different type of background, the different type of engineers, etc., both basic sciences, etc. So these are the few demand for the, as you can see, there is a rise of the all over the places. The electric vehicle demand is rising depending on the again these are the small. Also I'm telling that although academic research we can do in a small scale, for example, for a large scale battery manufacture, again people have been working with the different startups in related to the North American different type of the investment in the North American companies are working in this one. These are the small example with the Quebec. So again, in summary, why the energy is very important. You want to be a smart city, or you want to be smart storage, or you want to store solar or wind. I think batteries will play an important role. The main issue is that advantage of this using this battery operated RA, we can reduce the CO2 emission, and also other consequences that we can reduce the we can see the unpredictable rains. Again, the global warming. Always people are talking about the climate change. I think this is very, very important. I think always you have to reduce the CO2 emission in a different way, either use of electric vehicles or industry. We have to reduce the greenhouse emissions. We have to in a different way. That's why material play an important role. So regarding the battery, I think today we focus on lithium. Why lithium very popular? Because of the high energy density when compared to the other thing, and especially lightweight is also very important. That's why we are using these batteries for various applications. I think these are the different type of configurations are available. So since my time is up, so I'm going through different type of configuration. Again, if you talk about your electric vehicles, so there is something like 650 cells, nearly 7,800 100 cells they used to use, and they use some simple chemistry of the layer type of cathodes and graphite as anode for the quickly. I think what are the importance as academic research? These are the few examples how the Nobel Prize in Chemistry 2019 has given. Again, the innovation is coming from the university. That's why these are the few people they won the Nobel Prize in the chemistry in 2019. So quickly, I'll mention that if it is any battery electrochemical device, there is a positive, negative, and there is electrolyte. And we need some inorganic oxides. For example, if it is lithium-based, lithium containing inorganic oxides are needed. If we talk about sodium, we need sodium containing inorganic oxide. Another side is a graphite is the one, there is a negative electrode, and there is electrolyte, separator, etc. I think this is very, very important for the to make a small schematic cell. So this cell is ready. We want to make it to large scale. Again, the lot of engineering concept people have to work on this particular things. Since I don't have much time, quickly, it is like principle of lithium batteries is nothing but the secondary battery, which convert chemical energy to electrical energy. And what will happen during the charge, lithium move from the cathode to anode, where the electron will pass to the external circuits. It clearly shows that so these are rechargeable. That's why we have to see something like reversible peaks. It clearly indicate that again, the important point you have to remember if you do is electrical grid industry, we have to look for high energy density, adapt the climate conditions, and I think people looking for the fast charging is very, very important. Again, coulombic efficiency, impedance, etc. I think afterwards, people at the end we need to more safer material, low cost and toxicity and sustainability is very, very important. I think again the people may ask what is the importance of nanotechnology. I think materials should be smaller in size so that all the material is participating in electrochemical cycling. As a consequence, we can get a good high rates. So that's why it is very important. There is a lot of engineering. What is material manufacturing side? People have been adopting different type of strategy to prepare the material in such a way that you are able to get a fast charge. So I think what is the important point you have to remember. Another is the mining industry. Again, the raw materials. These are the different type of raw materials locally has to produce. It is not as easy. For example, coming from one raw material from North America to Indonesia or Indonesia to North America or North America. So it will cost another 20 to 30% because again sustainability concept of we point always is very important. People have to produce raw material in locally. As you can see, Indonesia also there is a lot of opportunity. I think Indonesia we can see the number one in the nickel mining. So there is a lot of interesting the nickel, say especially. So and maybe some few other things like for example iron, copper, phosphorus also. You get maybe copper also is possible. Maybe graphite is also. So what I'm telling that's why this is, nickel is very, very important if we talk about the sustainability because cobalt based mining is a little bit expensive. The people have to and also low cost, high cost of cobalt. So people are looking for the nickel rich cathode. That's why nickel there is a lot of opportunities, especially for the Indonesian side in terms of sustainability or circular economy. Quickly, I'll tell that material fabrication, since my time is up, again, the lot of chemistry or material engineering you can do. You can try to prepare the material in a different way. Although in a laboratory, in a small scale, we do as the industry, we do in a large scale with people want to be nearly 1,000 tons per year. So there is a large scale manufacturing already been developed with many Chinese companies, etc. For example, people are looking for thin film industry for electronic applications, electronic engineer some particular applications are plasmonic, they need something like a different type of shapes. Again, people can produce using the different techniques with various techniques. I think quickly I'm going to do, if you want to do a lot of physical properties, either you can do a sputtering in an instrument, you can do interesting physics, and again I'm telling that material research or material engineering or basic sciences, at least for any nanotechnology, we have to understand. We think we're using the various characterization techniques is very, very important, especially for the researcher. So that's why always is very important once you want to do read or something, always it is very, very important to understand how to characterize them, how to properties. For example, if you're a mechanical engineer, people looking for mechanical property. For example, in terms of maritime industry, electronical techniques are very useful. People can see how the corrosion protection, how we can avoid the rusting. So that type of things also, there is a lot of interesting electrochemistry we can do by using the galvanostatic cycling or voltammetry, etc., or impedance analyzer, so etc. So since my time is up, I don't have much time to discuss all this one. Again, there is a lot of, if you want to integrate into a smart battery, you can do by using this. So again, in terms of electrical engineering students are concerned, I think battery is very complex. People want to understand the a lot of electrical power, electronics, and electric machines. There is a lot of interesting work you can do with the electrical engineering point of view. I think people want to be smart charging. For example, so many cells are going to put nearly 7,000 on a cell. We need a smart charging, what we call as battery management. So all the cells uniformly has to charge discharge. Again, it is very, very important to understand. Quickly, I'll tell that these are the, in terms of the battery, there is the top is a cathode and bottom is anode. So these are a few examples that are used in the real applications. Since my time is up, I don't have to discuss too many details. Again, I'm talking about there is a lot of opportunities for Indonesia. There is in terms of nickel-rich cathodes, so again, there is a lot of opportunities. Again, I think you can do, again, in a laboratory scale, the small button cell you can do. In a real industry, everything is automated. People can prepare millions of the batteries in a large scale. I think all automated facilities are available in the market. Only a lot of investment is needed. As you can see, there is a real industry is concerned. There is a stocking, everything you can do depending on what type of the cells package you want. Again, people can do in this particular technology. I think in a laboratory you can do small scale. I think that is also available in the. In fact, I visited different places in Indonesia. I think we have already some few other R&D in Batam, like for example in Jakarta and few places in Surabaya. Also, I visited some universities already existing the battery facilities, and also some Padijaran and few other places already existing this type of research. Quickly, I don't want to discuss about too much details. Again, this year we Nobel Prize in Chemistry. I think development of metal organic framework has been done. I think after doing all this one, again, the always creativity is very, very important to this direction. In fact, we are at the National University of Singapore, although it is not a really, so these are the original idea done by metal organic framework from based on this work. And some of the first time we've been developed some metal organic, inorganic framework materials. Although we don't claim that this is a very high capacity, still there is a lot of opportunities for us to in this area. We can try to produce in high scale, like high performance material. I think quickly I'll skip to this particular portion. Again, either you want to do sodium battery or potassium battery. Again, a lot of understanding the material engineering and chemistry will play an important role. I think in terms of graphite, there is a lot of, since presently my focus is on graphite with research. So although there is a lot of opportunities, either research, they want to be a chemistry. I know we have been a lot of work in the research, etc. Again, so in general, the materials or nanotechnology will play an important role. Or they want to be sensors applications, or you want to be automobile sensor, or you want to be gas sensor, etc. I think materials play an important role. Also, for example, people want to see the monitoring the CO2, etc. Again, the materials for energy and environment. I think quickly, I think my time is up, so I wanted to quickly go through what are the importance of the, for example, another 2 to 3 minutes. So there is a battery, there is huge component. So that is very important, the battery catching fire. Otherwise, you have to understand the anode side. We don't want to do the fast charging. And also for the cathode also we can't do overcharge. That will also lead thermal runaway. And electrolyte also we have to use appropriate temperature, and separator also you have to accordingly. So these are all the very important point you have to remember. Finally, as you can see clearly, there is a lot of opportunity for the electrical engineer, mechanical engineering, and at the end you have to work with both basic science or etc. That's why once you get a device, it is very, very important. As a academic researcher concerned, you can do real-time X-ray. We can see the battery without opening, what is going to be happening, the charge, discharge, how the swelling or how the material transformation is occurring. That's why we have to read the SOP. Don't exceed the limits. Please restrict the what are the SOP safety operating procedures set by manufacturer. Try to restrict that one. So that is very, very important. I think I'm going to, anyway, as a research, you can do a lot of interesting things. Again, the one word is sustainability is very important. Whatever we do, we have to recover them. The materials, again, is very important. Although, if you, there's a huge technology is known, only if you don't recover the material, if you throw them into the soil, again, water contamination, etc. So that's why we have to recover the material, etc. Again, the technology is known, only the matter of the cost. And then my
Sorry
suggestion
for
is that
interrupting you, sir.
yeah,
Time is
yeah.
up.
So I'm going to conclude since my time is up. So again the materials play an important role, and then again the sustainability development will play an important. Again at the end, always you have to work with the scientists and engineers. Since my time is up, I'm going to stop saying that again. Salam alaikum and merci beaucoup. Thank you very much. Okay.
Okay,
I may take
sir.
some question and answer. Yeah.
Yes. Okay. Okay, ladies and gentlemen, first I would like to thank to Dr. Reddy for his presentation. Now we are in this question and answer session. I invite two persons of the audience, virtual and non-virtual audience, to discuss this session, to be involved in this discussion. Please raise your hand if you are from virtual session. Any question? Okay, we have one participant or one audience from the virtual. Yes, Daniel Simatupang. Okay, Daniel, time is yours.
Before I ask my question, let me introduce myself. My name is Ariel Kardinata Saputra Lingga. I'm from the Biology Education Department at Raja Ali Haji Maritim University. And my question is, what will happen if we reach a point where the essential raw material for technology become too rare or too expensive to extract? Thank you.
Okay, I think these are really, in fact, thanks for the young researcher we will ask. I think really very interesting point. In fact, there is a really issue. That's why each mining, you consider that there is a year like 20-25 years, like the particular area. So that's why geography, like for example, here based on that one, people have been concentrating always in terms of environmental, what they call sustainability. All the people are looking into this aspect, So my suggestion is that people may ask you that why, if it is rare earth, according to me, yes, it depends on how much quantity. If it is how many tons, So since we based on our requirement, like electric vehicles, presently which are the element they have, I think they have sufficient. So we don't know after 100 years what is the how much quantity it is required. That is the question mark, So that is one thing. And my suggestion is that slowly maybe technology, like after some times, for example, the question is that how to avoid this one. Only way is that to recover the material, in the sense that we can't throw the thing. For example, once you take the material, throw in dustbin or soil, again you're losing, again you have to prepare the new material. Best way is that take a existing material, recover that one, reuse it. So you have to reprocess, so automatically we can avoid the, okay, so in terms of the like what they call feasibility, I think sustainability. So that is very, very important. I understand the biologist, so especially other aspect also you talk, since you're a biologist, you may ask you that water contaminations, because there is cobalt, and sometimes that's why it's very important. Recovery, sustainability is very important, Yes, if you recover them, you may lose something like some 5%, 10%. So in principle, if you do a proper recovery thing, so we can, so again, sustainability, circular economy will improve. So that is my opinion.
Okay, thank you, Dr. Reddy. And we go to the next question. Comes from Daniel Simatupang. Daniel, time is yours. Daniel, please.
Again, thanks for the young researcher raising the questions. It is very, very important. Always try to ask any questions. That is very, very
Yes.
important. So since I work with a lot of young researcher with high school and junior, since the
Yes.
people are university, we are more
Okay.
mature, so it is really good. Yeah, please
Yes.
start.
Daniel,
Yes, ma'am.
Yeah.
Yes. Please take your time.
Okay. Okay, first, thank you for Dr. Reddy for your very insightful presentation. So, let me introduce myself. My name is Daniel Cristiano Simatupang, and I'm an English education student from University Maritim Raja Ali Haji. So, I was very interested in your slide that showing that Indonesia is the #1 producer of nickel. So, my question is, in your expert opinion, what are the most important steps for Indonesia to move from only exporting raw nickel to successfully building a local industry for battery materials or even the batteries themselves like that? So, thank you very
I
much.
think this is a good question. In fact, many researcher, like a young researcher asked, always in terms of sustainability, then at the end, so now is okay. Now initially we may buy from China or from India, buy from North America. By 1 or 2 years, okay. For long term sustainability, it is not a single car. We need too many. Everybody wants to a lot of car. At the end, the story is that once the technology is developed, people once the process is confident, everything is okay. We'll buy the technology. At the end, we have to prepare the raw material, everything in Indonesia, and fabricate the cell. You're doing all the cells and manufacture them doing a lot of since you have a lot of good manpower. I know I visited many Indonesian universities. They're very smart, good researchers are there, good engineers also there. It's not only it's a matter of training. Once you know the technology is there, after proper training, I think we are able to develop in a all real high electric vehicle battery in Indonesia. Need not to be so. It is only a matter initially once the technology has been like once we maturized and we need a government support or industry expert, they can invest on that one. Finally, we are able to prepare the raw material from nickel or in cathodes from the ore, like that is the mining engineering, followed by cell fabrication. Again, once you do cells already, then you have to assemble them. Then we need a car manufacturer. They will do. So again, for them is a battery pack and big packs. If you give it to them, you can buy in the supermarket. Is like buying the let us say a big pack like that type of things. It will come. So only your job is that putting that particular stack into your car and you can run like that way. So that is called at the end always. So that is the aspect. So that is the way everybody is hoping. And the end is minimum 20 to 30% of, for example, in terms of the greenhouse emission or buying from one country to another because you need to spend a lot of money in transportation. Again, that one we have to avoid. So that is the main objective. And also because we don't depend on interdependence. For example, after a few years, I will tell bye-bye, then it is really difficult. So, and that is very important. I hope I answered your question. Maybe if you have any comments, your opinion, then happy to take.
Okay, Dr. Reddy, thank you for your responses and thank you for your professional performance today for delay your nap because in Canada it's about 11 a.m. 11
Yeah, around like midnight,
Yeah.
12 o'clock. Okay, so anyway, sorry for
Yeah.
okay. I listen to I always I love to listen all the
Okay.
talk today. I'm a little
Thank
bit
you.
not so
Thank you.
energetic. I'll try my
Thank
best
you.
to listen my other speaker also. Again,
Yes,
sorry if I don't attend and a few other people. I'm very okay. Thank you very much. Thank
Yes,
you.
yes. I appreciate your professional performance for this conference. All right.
Okay. Thank you very much. But I hope to see you in future because I know that this time
Hopefully.
maybe in future some other conference. Happy to visit your
Hopefully.
university and your province. Okay. So thank you very
Hopefully.
much. Okay. Salam alaikum and thank you very much and merci beaucoup.
Waalaikumsalam. Merci. Merci beaucoup. All
I see.
right, all the audience, I end this session, and I return the session to the MC, and I would like to thank to all the committee of this Marinestic 2025. Thank you.
Kemudian informasi kepada seluruh Indonesia mendapat dari dana kementerian bahwa keuangan sebelah
Baik, Bapak Ibu dan hadirin yang kami muliakan, selanjutnya kita akan menyimak pemaparan materi kelima, sekaligus menjadi pemaparan materi terakhir dalam kegiatan Marinestic 2025. Pemaparan materi akan dipimpin oleh Ibu Hanifah, SPDI MPD, yang akan dilaksanakan secara virtual. Kepada Ibu, disilakan.
And finally, ladies and gentlemen, we will proceed to the fifth and final plenary session led by our moderator, Ms. Hanifa SPD MPD. To her, please welcome.
Okay, thank you so much. I hope that my voice is clear and everybody can hear my voice clearly.
It is audible.
Yes,
Good
Miss,
morning.
your voice is clear enough.
Okay, thank you so much. All right, good morning, distinguished guests, respected colleagues, ladies and gentlemen. Welcome to the keynote sessions of the Marinestic 2025, the Maritime Research on Innovations, Environment, Science, and Traditions International Conference, hosted by Universitas Maritim Raja Ali Haji. Okay, we are now in the second session of keynote speech. Then, let me introduce our keynote speakers in this session. Our keynote speakers, Dr. Tena is a postdoctoral researcher at the Department of Mathematics and Science Education, specializing in science education, STEM and STEM learning, and environmental literacy. She earned her PhD in education with excellent cum laude distinctions, and focusing on design-based research and environmental science learning in primary classroom. Her outstanding academic journey includes participation in numerous European projects, such as Horizon 2020 and Erasmus, aimed at improving science education, promoting sustainability awareness, and empowering teachers and students to engage with real-world scientific challenges. She has published extensively in leading international journals, serves as editor for several science education journals, and has delivered invited talks at major global conference, including ESERA, if I'm not mistaken, the pronunciations. Okay, today Dr. Tena will deliver her keynote address on the topic, promoting environmental literacy through science education, bridging research and classroom practice. Her presentation will explore how science education can foster critical thinking, environmental and awareness, and sustainable actions among young learners. Okay, ladies and gentlemen, let me invite our keynote speakers, Dr. Elia Tena, to deliver her keynote speech. I hope that I don't mispronounce your name. Okay, please welcome Dr. Elia, Dr. Tena. Then you have 30 minutes to do your presentations. Thank you so much.
Thank you very much for the invitation, and don't you worry because my name is even hard in Spanish, so don't you worry at all. Thank you very much for the presentation. Let me try to share with you. Yes, share. Good. Let me check if you could see. Okay. I think that now you could see all my screen. Could
Yeah,
you
we can.
confirm it? Yeah. Perfect. So as it has been introduced, today I would like to talk about STEAM education and this idea of STEAM literacy and why this is important, not only for students, but also for you as a future researcher, as an actual researcher, and everyone. And despite that, it's me who is going to deliver this session. This is not my only work because I'm working with closely with some colleagues, and here you could see two of them. One is Digna Couso and the other one is Cristina Cimarro. They are trying to think also in this topic in Spain, not at the same university. I'm from Autonomous University of Barcelona, and they are in others, but we talk together about these topics, and the insights that I would like to present today are also from them. Why we start interesting in STEM, and the reason is that STEM is everywhere. At the very beginning, we start looking at STEM, and others in documents from the policy that came from the policy that mostly say we need more scientists. In our case, Europe need more scientists, and this means not only scientists but also engineering people who is from mathematics parts and so on. And each country in Europe and as I could see on internet in Indonesia happened something similar. Adopt this idea of using STEM and concrete a specific program. Here, these three of them are from Indonesia, as I could see in the internet. But apart from this policy document, we always see STEAM in kind of communication project and so on. Here you could see some of the most important ones, like the Lego League and so on, that trying to promote especially women who came to STEM, that came and wants to develop their STEM career. But finally, in the last year, we start looking on STEAM on even in the toys that we could buy for our students. So despite of that, there is not a consensus in the international literature on how does it mean STEAM education and what does it mean STEAM education. Why? Because there are people who start asking what science and which aspects of science do we need to teach. Same for engineering, and especially this idea of the engineering is something that we need to use, or we need to focus on this idea of design. Mathematics have some similar problems. And then in the last years, we include STEAM with I, and this is also something problematic. When we go to the schools in Spain, but also in Europe, what we see is that our teachers, our STEAM teachers say, okay, but this STEAM means a new content, we need to teach something different. This means new methodologies, we need to use new methodologies to teach them. Or this need the use of new technologies for schools. This is a matter of resources. And based on that, we start thinking on the topic, on searching on the literature. And what mostly on the literature says is that STEAM needs to be for schools a matter of facing the challenges that citizens have. And this means that all the citizens need to have at least some literacy on STEM. And this means, on the one hand, that one of our objectives means to foster STEAM literacy for all, and this means capacity of all citizens to be involved in STEAM, despite they are not going to be STEAM professional. And on the other hand, to promote critical and not negative stance towards STEAM. Why this? Because as we see in Europe, there are few people from some social classes that wants to become a STEAM professional, and not only that say STEAM is not about me, and I don't want to be engaged on nothing to say with STEAM. considering that, what we start doing was to start thinking on what do we understand this STEAM literacy, and we develop now we develop one definition that you could see here. This idea of STEAM literacy is the ability to identify, apply, and integrate both key knowledge and ways of doing, thinking, speaking, and feeling in science, engineering, and mathematics in a more or less integrative way, to understand, decide, or act on complex problems and to build creative solutions, and taking the advantage of personal synergies, available technologies, and to doing so critically, reflective, and with values. This is a definition we already use, and it's based on Balka 2011. So mostly this definition put the focus on four main aspects. The first one needs the STEAM literacy needs to be competence-based, needs to involve students in the STEM practices, it needs to be in context, and needs to use this idea of resources and values. You could see here. And now the question is, okay, but how can promote this STEAM literacy in schools could help me as a researcher, or how can I contribute to this? Because you could say, okay, this definition is amazing, but how? So now, what I would like to explain is a story or an example of that I was living. I was participating in a project, in a European project, where a group of STEAM researchers on environmental science wants to analyze the potential impact of air pollution exposures on attention of 15-year-old students. And what they experience say is that they have low engagement from the students, limited teacher understanding, and research was only benefit, the benefit of research was only for these researchers, but the community, the society, the students were not really benefit from that. And we start thinking in collaboration with them in a new opportunity to students genuinely participate in real science and were really engaged, an opportunity to involve not only students but also teachers in this process, and also thinking on an opportunity to meet real and not the stereotype people who work in science. And to do so, what we did, is to start collaborating and start thinking on how can we develop a STEM school project from 15 to 16 years old, but then we extended to from 10 to 16 years old. And encourage them to take actions in their community. So in the first phase, we involved 35 high schools and around 2,000 students. And to do that, I'm not going to go in deep on this because I can deliver one keynote about any of them. But the idea was to build on the research on science education.
Excuse me, Dr. Aurelia, your presentation is stopped.
Sorry.
Yeah, we cannot see your slide.
Okay. I will try again. I'm going to share again.
Thank you. Sorry.
No. Could you see now?
Yeah. Okay.
Okay. Sorry. As I was being said, we built on the ideas of science education. There is a huge number of people who is researching on how to learn better in STEM. So we built on that, for example, on the idea that initial ideas of the students were essential to be considered in the project, the idea of few but high relevant ideas about and of STEAM, the idea of cognitive but also physical engagement in scientific practices, the idea of context, and this idea of help them by promoting their use of science. So what we did is we started with the definition, and the idea was to first identify why the context was important. We we clearly identified that scientifically was important, air pollution was important for them. But what we tried in this process was to identify if socially was relevant. So the main question we did to ourselves is, why is our research topic relevant for science and society? And how can we encourage students to take an active role in our topic of research? Because this idea of act in to improve the situation. The second one was, what are the main ideas the students need to know to be part or to be able to participate in this phenomena. And we developed this idea, these three main ideas, consensus with teachers, with science education researchers, and also epidemiologists. For example, this idea of air pollution, what is air pollution and what is air? What is the effects on our health? So how can be exposed to pollution can be affect to ours? This idea to empower the educational community and students, especially to make decisions. And finally, we identified that this connection with different stakeholders can help them to have a better idea of what science means, what is a scientist, and so on. So this idea, what we ask to us is what is essential for the students, and also what are our expectations. And this could change depending on the age, because we were in a compulsory school for us. But if it's not a compulsory, we need to change on that. And after we decide which kind of specific STEAM practices we want to involve them, and we decided this, modeling and inquiry, and specifically this idea of students need to express their idea, facilitating the acquisition of new evidence, and express their final ideas. And in case of inquiry, that means this idea of developing skills and competence to think on how can we do an experiment and so on. We decided to involve them in formulate and identify research questions, plan and conduct investigation, develop research instruments, and analyze and interpret data. I'm going to explain a little bit more about inquiry, because I think that it's the more interesting part. But mostly what we think on that is which scientific practices of doing thinking and communication about science do we want that the students to develop, and in what ways we can, as research, contribute to this development. In case of the inquiry, what we did is at the beginning to ask students to think on their own research on air pollution in their schools. And here there is one of the questions that one group of students did. They say, is there any difference in air quality between the 15-year-olds classroom on the 3rd floor and the 1st floor in our schools? And they collect data with this device. You could see here one of them, and they have this kind of graph, and they use it to think. But the most important or interesting part was that after participating in school science, they contribute to real science by participating in a elaboration of a questionnaire regarding to the effects, the aspects that can affect their attention. So we asked to each group of participants to send us, as a researcher, around 10-20 questions for making a questionnaire that for them was interesting to know if they affect or not to their attention. So then we analyze these questions, because there are some of them that are equal, so we join and so on. And we finally did a shared questionnaire that it was published here, because they the results give us some aspects that no one's before take into consideration. In our case, for example, the use of energetic drinks was something that was statistically affecting them, and not any research previously explored this idea. So we discuss here that the participant of students is not only a beneficial for us, but also a beneficial for science, for society, and for students learning. And finally, this idea, we use was a PM sensor, and we use this, but also it was really, really relevant, this idea of not only technological resources, but also personal resources. It was really, really relevant. I'm going to share with you some insights from the students that scientists, and especially girls scientists, goes to the schools and present themselves as a person who was engaged in science, who was participating in science, and how was this participation. And finally, this idea of taking in mind with values we want to communicate. So in this case, what we think is which personal and material resources do we need, and which values do we want to share with the students, and what is the idea of science we want to convey, and science for whom. Because when they present themselves as people who have really a career in science, but also other interests, other or a family. They not live in the lab, because the students think on scientists as a person, mostly men, mostly from a specific culture, mostly. So try to face these stereotypes. And finally, after being participating on that, we ask for the student for a solution. We share with them some of the plans that or actions that governments do. This is a panel, like a garden, vertical garden. Then we offer them the possibility to communicate different people in science who is thinking on that. These are 2 researchers, and there were more. And then ask to act on that with the idea of design thinking process. And they did a game, they develop a game, they develop a campaign for their schools, and so on and so forth. So the idea, our final idea was, okay, what should the students do with the knowledge they build during this process? This is an overview of the different activities they were engaged. And what I would like to tell you is, despite I'm explaining the final version of this story, there were a lot of versions in the middle, because there are some activities at the beginning was not working well. Then we refine and use another one, and so on. We were engaged 2 PhD research on that. So we focus on these activities and think, okay, what students learn on that? What are the main milestones? What are the difficulties that they need to overcome on that, and so on. And this is some key insights highlighted by each stakeholder after their participation. So students mostly highlight, when we ask them what it was the better aspects on this experience, they mostly highlight 2 aspects. The first was the relevancy of participating in science with scientists, and this idea of breaking some stereotypes. For example, there was one that said, I was quite surprised by how young the scientists were. I had imagined they would be much older. Still, they explaining everything very clear and answer all questions. Their experience was evident. And this was an insight for us, because I say, okay, these students still being thinking on men, on old men, and mostly on imagine people explaining things that they don't understand, that they cannot understand, and to be in contact, to think really on not being the first aspect to do, but have an engagement, a contact in several phases of the project, was really interesting for them. Then another aspect was this idea of being aware of environmental problems in their context and promote the citizens' participation was something really highlighted by their students. For example, one of them said, this project helped us to understand the importance of knowing and caring our environment, because it's a place where we all live together. So this idea of engaging students on this kind of activities can help us to them being really aware of that. But we have also some insights from teachers and from researchers. The teachers mostly highlight this idea that participating in real science, where we don't know what is going to happen, what is going to emerge from the experiment, it was really, really relevant for them, because they have the impression that all the school science, we know what is going to happen after the experiment. And to be really engaged on these processes helped them to discuss with the students how science is developed, and that there are aspects that we don't know it, that there are some results that we don't expect it, that there are some others that we expected once and it was the contrary, and so on. And the second aspect that they really develop is that was a deepness in the content. So the teachers says that the deep with which is the topic what that was explored was essential for them. It was not like we call it like people who is talking without knowing nothing, but the contrary. So going really in deep, think on really on the problem, think on really what are the consequences, what are why is a problem, and so on. And finally, in regarding to the researchers, all of them told us that the participating in this project help them to rethink their works and think on the citizens when they explore, or when they are trying to think on the future research. So they one of them say, for example, for me, it was mainly helped to explain things more clearly and to reflect on what we do matters to them. I believe that it has happened. Students see scientists as ordinary people and to think critically about how research is carried out, even questioning our methods, because they identify that the students were really engaged on the topic. They know a lot of that, and they say, okay, but why are you doing this now? And if happens, if the result is this, we could think on that. And there were aspects that they don't think before the participating. So this is the experience on air pollution, but there are other inspiring examples that could be good for you. We are using more or less same approach to develop an antimicrobial resistance teaching and learning sequences in collaboration with people who is trying to think on alternative to antimicrobial because of their resistance. But other initiative, for example, these are two initiatives. This is the first one that it's called like Clean River, and it's a citizen science app where students can use with their families and go to the river and try and send data to the scientists to monitoring the different rivers in Catalonia. That is where I'm living. This in the down part is about more is in the beach, and there is a group of people who is really conducting research on plastics on Catalan beaches, and they are trying to focus the research on that, and they engage students to collect data from the sun and to count how many kind of plastics and how much plastics they found and so on. And this is, if I'm not wrong, 15 years running, so it's quite long. And there is this is a review. This is an initiative that students came to our university to do a specific workshops on science education to meet other scientific people. And for example, we conduct one regarding to this balance on the oceans and the problems with acidifications and so on, and trying to understand what is happening, what could we do, and so on. And if you want to know more about these ideas of STEAM, how students participate, what was exactly the material, you could see here some insights that we publish, but we could send as
you only have 1 minute left.
This you could see here the materials, and thank you very much for this opportunity.
It's right
I'm really open.
Yeah, okay. Thank you so much, Dr. Elia, for such insightful and inspiring presentations. Now we will open the floor for Q&A sessions, which will last about 20 minutes. And we kindly invite participants to share their questions with our keynote speaker or share ideas, so of course. And if you are joining us online, please click the raise hand button or type your questions in the chat box before asking. We kindly ask the participant to mention your name and your institutional affiliations, not only for the online participant, for the on-site participants. You may also asking questions to Dr. Elia. Okay, let me check the on-site participants. There is someone raising hand. Somebody maybe can help me to check it.
Okay, let me introduce. My name is Gefira Tuzahara from Raja Ali Haji Maritim University, Facultas of Teaching and Education, Biology Education Study Program. Okay, the question, what are the main challenges in implementing educational STEM in school with limited research, and what solution can be implemented? Okay, thank you.
Okay,
Thank you very
Dr.
much
Eli,
for
you
your
gonna
question.
directly answer the questions, or we gonna collect several questions first? Okay, maybe we're gonna collect the questions. All
Okay.
right. The next questions from, still on-site participants. Please mention your questions. Yeah.
Okay, thank you for your time. First of all, allow me introduce myself. My name is Gadis Vika Aurelia from the Biology Education Program at Raja Haji Maritim University. Well, the question I want to ask is what is the most effective technology used in education to remind students of their understanding and skill? Okay, that's all. Thank you.
Okay, maybe the last questions for this session. If we still have a lot of questions, then we're gonna open it again.
Yeah, if there is questions that I cannot answer because of the time, you could send me an email to any participant. So.
Yeah, absolutely. Okay, please.
Okay. Thank you so much for Dr. Elia Tena for your explanations and your insightful presentation for today. Well, my name is Octavia Bahakeni from English Language Study Program. My question is, how does STEM literacy influence an individual's ability to engage in evidence-based decision making, and what pedagogical strategies are most effective in developing STEM literacy among students at various educational levels? Thank you.
Okay, it is clear, Dr. Elia, or should we repeat the question?
No, I think that it's clear.
All right. Okay, now we have 3 questions already. Let's come to Dr. Elia, please.
Yes. If I'm not wrong, the first question was about challenges and regarding to field research. So, despite we have field research, the only way of continue having evidence of what works and what does not work is continue doing research on this topic. So, being participant in this in STEM projects is essential to know what is working and what is not working. Despite of that, it's true that there is not a lot of evidence on STEM education, but there is a lot of evidence in terms of science education, engineering education, and math education, because there is a huge tradition, around 50 years of tradition of research on these topics. In our case, we start with these ideas of what science education research says about how we need to learn in schools, I don't know. And then continue with this idea of, okay, how can use this to integrate, or what is essential not to integrate, or to think on that and then to come back and integrate in other ideas. So for me, this is a starting point. We need to still having research on these topics, and we know several colleagues of you that are around Europe doing their PhDs focus on these ideas of how can we develop this STEAM education. The second one, it was this idea of technology to develop skills, and there is not only one technology that can develop all the skills, but we have a lot of technology that can help us. For example, we use a lot of sensors to collecting data with the students, not one specific sensor, but a lot of them. For example, movement sensor, light sensor, there is a forces sensor. And each of them can help us to collect data with the students as they were scientists, and to analyze them and to think what we see. This is agree with our hypothesis, our initial ideas, how these results change our ideas. Is the result obtained, or the results obtained agree with exactly with the theoretical framework, or there is something that is strange in our data? What can happen, and so on. This is so there are not only one, there are a lot of them. There is also AlgoDo, that are mostly some simulations. Pez Colorado simulations, for example, are really interesting. But there are a lot of technology that you need to search in regarding what you want to do. And finally, this idea of how does STEAM evidence and regarding to the skills and so on, and how to still developing. As I have been said, we have some ideas on what are the skills we need to develop. I mean, if we want to students be engaged on STEAM, what are the skills that we need to engage on them? For example, making questions is essential for developing the science literacy. Collect data is essential. But in case of engineering, for example, these are a little bit different, because it's much more important to optimize a solution, to think on solutions, to collect data, to know if the solution or testing the solution did to prototype and so on. So the idea is to combine them, to think on these ideas that the science education research have been highlighted, to still developing them during a period of time. If I'm not wrong, these are mostly the questions you already did.
Yeah, I think that all of the question already answered. All right. If there is another question, we still open an opportunity to discuss with Dr. Elia. Maybe from online participant, if there is questions. Yeah.
I've already sent my email through the chat. If you want to share with all the participants, it's okay for me. If at some point you decide, oh, this girl was talking to me about that, and now I need an idea of, you could send me an email.
Maybe for several days thinking about this stuff. Then
yes.
Oh, I need to know more about some.
Yeah.
Thing. Yeah. Then.
Yeah.
We're gonna contact you, Dr. Elia. All right. It seems that there is no other questions from participants. Yeah. I think that your explanation, your presentation is really clear. A lot of examples, and of course, it gives us inspirations. Yeah, to apply or to implement STEM in at school or in our class. Thank you so much, Dr. Elia.
Thank you very much.
Yeah, I think we finally reach the end of this session. Yeah, thank you so much. Then I think as a moderator will end this session. Then I will go back to the moderator of the Marinestic on site. Thank you so much, Dr. Elias. Yeah. Last I will say Assalamualaikum warahmatullahi wabarakatuh. Thank you so much. And then we're gonna go back to the moderator.
Bapak, Ibu, dan hadirin yang kami muliakan, dengan berakhirnya pemaparan materi yang kelima akan menandakan berakhir pula kegiatan kita pada pagi hingga siang hari ini. Namun sebelum kita mengakhiri agenda kita pada pagi hingga siang hari ini, kami mengimbau kepada seluruh narasumber dan peserta, baik yang hadir secara luring maupun secara daring, untuk dapat memindai kode respon cepat yang ada di depan. Berikut adalah kode barcode yang teman-teman bisa scan untuk bisa mendapatkan e-certificate untuk kegiatan MARINESTIC 2025.
Before we close today's event, we urge presenters and audience members, both on-site and online, to fill out the MARINESTIC 2025 e-certificate barcode form. The e-certificate will be sent to the email address you provide.
Kami juga mengingatkan kepada seluruh peserta dan hadirin yang ada di sini untuk dapat tetap berada di tempat karena untuk makan siang nanti akan dibagikan oleh panitia.
We kindly ask all attendees to wait for a moment for lunch provided by the committee. Please wait in the room to receive your meal.
Bapak, Ibu, dan hadirin yang kami hormati, berakhirlah sudah seluruh rangkaian kegiatan MARINESTIC tahun 2025 yang diselenggarakan oleh Fakultas Keguruan dan Ilmu Pendidikan Universitas Maritim Raja Ali Haji pada tanggal 31 Oktober tahun 2025.
Ladies and gentlemen, with the conclusions of the previous speech, we have officially reached the end of the entire series of events of Maritime Research on Innovation, Environment, Science, and Tradition International Conference that is organized by FKIP Universitas Maritim Raja Ali Haji on this memorable day, October 31st, 2025.
Semoga ilmu yang diterima dapat bermanfaat bagi kita semua. Terima kasih atas segala perhatian dan mohon maaf atas segala kekurangan. Sampai jumpa pada kegiatan MARINESTIC berikutnya. Karena tadi sudah diawali dengan pantun, maka kita akhiri juga dengan pantun. Dari irian banyak cendrawasih, banyak ragamnya terbagi-bagi. Cukup sekian, terima kasih. Semoga esok berjumpa lagi. Wabillahi taufik walhidayah. Wassalamualaikum warahmatullahi wabarakatuh.